Okay. Should see YouTube showing up here shortly. Excellent, excellent. And we'll start a next.com the everything application. All right. Yo, what up, my lass? Yogurt. All right. Add everyone. Learning Effect TS today. PogChamp. Teej DV. Productive week, eh? Yes, yes, of course. We don't have a full week marathon live stream event to plan that involves the coordination of 20 people in a separate state while we try and solve a video game. We can get back to streaming. It kind of changes the game, huh? Kind of changes the... Who this new streamer? I'm so funny. I'm chat. I have the funniest ideas. That's my Kit Boga. Rise and grind. Hey, what up, E? No music? We've got a guest coming today. All right. Let's see if we can get our guest on. Oh, yeah. Whoops. I need to do one thing first. All right. Hodl chat. 1 second. Yo. How's it going? I'm doing great. Nice to meet you as well. Let me get you into this Discord call. 1 sec. Window capture. And let me do... Here we go. Wonderful. Thank you. What is this going on here? We'll just delete that. We'll try this again. I really wish window capture would let you keep the window that you were capturing. That's crazy. Yeah. Discord. Nice. I am showing this. Very cool. I showed my calendar to chat. What's up, chat? Take that. Cool.
Oh, are we on? Are we live?
We are. Oh yeah, I should have said that probably.
Okay, no, I'll keep everything good then.
Stop talking about bun like that.
No, bun, no.
I'm telling Jared.
There's my face.
Here. There you go. Okay.
He's coming from me.
And
there I am. You're moving me around.
I am, yes. Now we are 2 talking heads. Very cool.
We're so close. Yeah, can you move me closer to you?
Yeah,
we're like overlapping. It's beautiful.
HR. Here we go. I'll make myself slightly. There we go. I'll go here. Okay, awesome. No, now I'm too big. Now it looks like a big bro, little bro kind of situation. We don't need to start any Vercel drama. So, all right, there we go. Perfect. Here we go. Okay. Now we're ready to begin. I think I've done all of my special stream things, so we're set to go.
Beautiful. Beautiful.
Great. Okay. Well, nice. Kit, this is the first time we've actually get to talk, not IRL, but as close as we can get with the powers of the internet.
This is the closest thing to IRL that exists.
Yes.
Anymore.
Yeah, for Twitch streamers. Not. Yeah. I don't believe in the outside.
We're practically overlapping. Yes. This is perfect. Yeah, it's great to meet you.
I just realized too, I can make it so you can see this live by going
Mm.
here, and I can.
Okay, that's very cool. Yes, because as everyone's going to find out, I did something rather complicated.
There we go. Cool. So now you should be able
And
to
so
see me and my. You're seeing exactly what stream sees now.
oh, perfect. Yes, I see me many times. This is great. Facing different directions. This is perfect.
Here, I can turn. Are we at different chat? Are you saying we're at different volumes? Oh, here. Let me try. Go again. Keep just talking for a second.
Hello, hello. The tip of the tongue and the teeth.
There we go. How's this chat? Is this better? I can turn myself up just a touch as well. Much better. Much better. Nice. Okay. I'll monitor the volume a bit, chat, as well. Okay.
There we go. Are you okay with this?
Yes, that's perfect.
Are you okay with this?
Oh.
No.
Nice.
Now, don't do your butt on stream, please.
Yeah, whoa,
no.
Guys.
Whoa,
TOS, man. TOS.
We're going to get banned. Oh, shit.
My last stream. Was this all a plan to get me to write Effect without having a job? No, I have to make productive software. I can't just make stream projects. Is that a new AI company logo? That's so funny.
Yes, my cat. It's called Worms.
Yeah. Cat AI.
Asshole.
Yeah. Well, anyways, Kit, why don't you give yourself a little introduction to everybody and then tell them what we're gonna do today? Because you're in charge.
Yeah.
You're in charge.
I'm in charge. Okay.
You're in charge.
All right.
Yep.
This is nice. Well, first scale me up. No. I like being down here. So yeah, hi everybody on Teej's stream. My name is Kit, and yeah, what do? I don't know. I'm a programmer, obviously.
Nice.
Probably obviously. I'm not sure how many non-programmers you have on here.
Not very
and
many.
Yeah, I'm here to be a humble emissary. If anyone's ever read Ursula K. Le Guin's The Left Hand of Darkness, I am an ecumenical emissary from a faraway land. I've come on a solo mission to present in sort of a peaceful, inviting way effect systems to Teej. And it's for him to decide whether or not they're worthy and thumbs me up or thumbs me down and, behead me in front of a TOS violation.
We'll end this with a gladiator style decision.
I think
I decide whether Effect TS repo gets deleted or not.
Yes. I haven't told Michael this.
That's actually a hilarious premise for like an open source series is like, put your whole repo on the line. Come let it fight it out in the arena. If we don't like it, delete the repo.
Yeah, it's GitHub on hardcore mode. Yes. I think that's appropriate. I've worked for years on this project, and it's time to purge it.
There's no way to get it back afterwards either. GitHub is
no.
GitHub is where the code goes. There's nothing. It's not built on top of anything. Yes.
It's the main.
Mm-hmm.
But yeah, so I guess that's the premise as concisely as possible. I do have some questions for you, TJ, and you as a proxy for probably your audience's interests and background.
Yeah.
Which is so I posted on the weekend. I wanted to teach some people Effect. I wanted to like practice some curriculum.
Yeah.
And you reached out. You said, pick me. And then you messaged again. You were the only person to message twice in a row. Comment is saying, "I'm serious."
I'm serious. Yes. Well, if I reply with eyes emojis, I felt like maybe he feels like I'm memeing. I just wanted to be clear. Like I was like, yeah, let's do it.
No, that's fair. That's completely fair. Mm-hmm. But what's piqued your interest? What is I'm just curious, your vague assessment of Effect, and why did you want to learn some more?
Yeah, well, in general, I like technologies that other people don't like. No, just
drama. Oh yes, now it all makes sense for the views, the controversy.
We're rage baiting. No, the main reason is some people that I really like, but primarily like I would say Dylan Mulroy, but other people in the Effect community like it quite a bit. I've talked with Dylan like at length a few times about Effect. I think TypeScript has a very powerful type system, right? And that if people want to spend a lot of time and energy and sadness like fighting the compiler and making it happen, you can make ridiculously cool libraries on top of TypeScript, right? That are not possible actually in like lots of other languages.
Yes.
So it's interesting to see people take, shall we say, like sound ideas and then build something with that type system to let you hopefully build like better software. That is the intriguing part about it for me. Like my dream of seeing OCaml be like a mainstream language. Can it, it's like there's like an echo of that if Effect gets popular and OCaml stays not popular and Jane Street just keeps printing money with it. Like that would be, that's still a cool outcome. So I mean, the like very short answer is just Dylan likes it a lot and I like Dylan. That's good enough for me to try it at least.
The transitive property of
Yes.
Dylan's
Yes.
interests. That makes perfect sense. Is there a tiny cursor on my face? I see a small smudge, but I
Oh,
think
yeah,
it's
you're
part of
so right.
the
That's
screen.
that's my
What is that?
my screen
Get that out
capture
of
is catching my mouse. Here, watch this.
here.
Show
It's
cursor.
such a tiny.
Done. Now it's not there. Good
Oh
call.
wow.
Yeah.
It did the opposite of what you commanded, but
Yes.
that's fair. You've got to reverse
It's not written
psychologize
in
the
effect, so
cursors.
it's not. You can't know. It's unknowable. Yeah.
A clap on, clap off situation.
Yes.
Well, cool. Yeah, that's great. Yeah, I see you have an interest in the objective categorical abstract machine language.
Yes, I like that one.
So that's interesting. Yeah, I've is Reason ML was that written in OCaml?
Yes, and
Okay,
still
okay. That
like is yeah, that one's a little bit complicated, but like Reason is just a syntax front end to the OCaml compiler. So it is OCaml. Like,
Okay, I'm
yes.
sure there's some many details there, but okay, that's my only experience
Oh,
with
nice.
OCaml through
Yeah.
Reason from a few years ago. Yeah, I
Yeah.
tried basically everything but JavaScript. I've sort of my entire career is formed out of avoiding JavaScript, and
Nice.
so every variant, pure script, GHC.js, Scala.js, obviously
No, yeah.
TypeScript.
Yes.
Uh, you
Everything that
know,
compiles to
so
JavaScript. Yep. I know the
anything but
feeling.
JavaScript.
I know the feeling.
Elm, yeah. So very similar. I relate with what you're saying about OCaml. While that wasn't my functional language of choice, just because of whatever path dependent
Yep.
reasons, I started Ruby on Rails.
Nice.
I went to one of those boot camps about 9 years ago, and they hired me. So the pyramid scheme of boot camps, it was very nice and fun though.
Nice.
And it was back before it was all scammy, so
Yeah.
it was kind of nice, and therefore went out of business almost immediately after.
Got cannibalized
It
by
wasn't
the people making impossible promises.
Yeah, the scammier people won
Yes.
out. The boss was too generous, I'm afraid. And But anyway, so I quickly after I liked Ruby on Rails a lot, and it informs a lot of I think my sense of developer experience and whatnot. But the lack of types really gave me an ulcer. I didn't know why. I just knew I was having an ulcer forming and a lot of anxiety, and so I sort of fled. First through Elixir, actually, because that's
Nice.
created by Jose Valim, who was a
Yep.
Rails 4 contributor. I saw you doing that yesterday on
Yeah.
stream. And that taught me about pattern matching and immutability. It gave me just a little clues. It slowly titrated the functional mindset into me,
Yeah.
um, instead of overwhelmingly. And then I found Elm, which was like Haskell with training wheels,
Yep.
a
Yep.
simple baby Haskell. And that sort of, white space function application. Like, how is that physically possible?
Where are the
I,
parentheses? This doesn't make any
I thought you
sense.
needed them to like keep the arguments in,
They're just gonna
physically, or are
fall
they best?
out. Guys are gonna fall
What are
out.
you doing?
You have to keep them here.
Exactly. I was very afraid, but then you learn that okay, it's all syntax, fine. So slowly figuring out how computers work, and then I got into okay. I heard about like whisperings of monad and functor in the distance, and I was like, okay, what's happening?
Yeah.
There's wailing in the basement. I want to go down there and see what monsters lurk. I want to conquer. I want
Yes.
to understand.
Exactly. Yes, it's okay to learn things and get better at them, and to make scary things not be scary anymore. Yeah.
Yeah, and I wanted to look under the bed, and I did, and I was cursed for a few years for doing that. My mind was broken. I wrote everything in a point-free style. I went too deep.
Yeah.
No, referring to a name, naming your arguments is gauche. Everything must be combined with parentheses and dollar signs and other Unicode characters.
Yes.
But I unlearned that slowly, and finally, wanting to find a Haskell job, found therefore a Scala job,
Yeah. A tale
which
as
was
old as time,
industry.
really. Yeah.
Yes. You look for Haskell and you find what you needed, I guess, instead. And I slowly, over time, fell in love with Scala. It was brutal at the beginning, though. It's a very complicated language, maybe the most complicated language because it's all the complexity of the JVM and object-oriented programming, plus all of Haskell and functional programming.
Yeah.
Yeah, it's insane. And metaprogramming. It's very fun though.
Yeah.
got addicted. And in that language, there was a functional effect system, and we'll talk more about what that means and what that is,
Mm-hmm.
called VO, which was fresh, just created, the hot new thing for the
Yeah.
2,000 people who used Scala professionally.
Mm-hmm.
And I started contributing to that, and ended up sort of doing a bunch of videos and whatever, working with that, and conferences for that very niche world,
Yeah.
for a few years. And turns out, about Michael Arnaldi was also looking at Zio about 5 years ago.
Mm-hmm.
And I actually met him in Spain about 4 years ago. He's the creator of Effect. And he said, "Hey, Kit, I'm working on Zio, and I want also to work on Effect." I really liked Michael Arnoldi's accent because he is Italian, but for some reason it sounds Transylvanian, and a little bit like a vampire, which gives him an immense gravitas to me. I don't think I've ever told him that. If you're watching this,
It
Michael,
sounds so much more Eastern Europe than Transylvania. It sounds all the way deep. He is in Siberian prison working on Effect when you do his accent.
well, that's all I got. So yes, he's like, "I'm working on porting Zio to TypeScript," and I was like, "What the? No, get away, back! Get me behind me,
Yeah,
Satan!
exactly.
I don't want to do
Right.
the accent. No, no.
Mhm.
But and I wasn't interested at the time. I thought
Yep.
types, whatever, JavaScript, it was too poison for me,
Yep.
and I was like, "That's cute." Scala is, though, the idea, much like you must feel about OCaml. Like, this is perfection. This is everything I ever want. This has algebraic data types that you can actually use.
Yes. Yep.
Oh, on the Effect Discord, I just saw a vampire emoji come in. So Michael, someone's listening.
Someone's listening.
Watching.
Oh no, we're in trouble now.
I'm in
We're in trouble
trouble.
now. I mentioned this was live, right?
Oh shit! I thought it was just the two of us. So yeah, he said he's porting it, and I was like, okay, cool. Best of luck. You seem like a smart and lovely person. Whatever. And then over the next 4 years, as Scala slowly sort of plunged into oblivion, and I realized just how hopeless the cause was for such a niche and complicated language. I kept seeing Effect show up on the timeline. I kept
Mm-hmm.
looking back, and the numbers had doubled and doubled. It was an exponential sort of takeoff situation. And then about
It was
6
even
months
just
ago,
getting bigger. You're like, whoa, that's cool. The number is going up.
yes, just that was like, huh, that can happen. I thought we were all just kind
How?
of huddling and trying to ration our code enjoyment until we died. But apparently no, it looked like it was taking off, which makes, in retrospect, so much sense.
Yeah.
JavaScript is used by everyone. TypeScript is used by everyone.
Right.
And this is why we could talk about like OCaml versus TypeScript, and why I'm going to recommend selling out, and why selling out's a good thing is going to, I guess, be the name of this talk. But yeah, and then I saw Pocock, who I was not aware of before, just because I was such a insulated man in my Scala world.
Yeah.
But he's a very astute. I won't do his accent because it's too powerful, and I'll brutalize it, I'm sure. But he dropped an Effect video, something like the language with a horrifically ugly syntax that will kill you, that I nonetheless fell in love with. Cyrano de Bergerac language. He was compelled by its poetry, despite being repelled by its physiognomy or whatever. I'm streaming now. I'm just going. Does this happen after you practice enough? Like, this stream of consciousness
Oh
takes
yeah,
over,
that's
and
what
you're just
chat
kind
wants
of a
to hear.
vessel?
They don't want to hear you say something prepared. They just want you to randomly start doing an accent and then have Mike show up in the Twitch chat. Like, that's what they want. They want that to happen.
Good. Okay. Yeah. I'm a humble vessel now, for whatever comes, from Effect. I speak for the Effect code base here.
It was crazy.
Anyway,
He's just been saying, Kit's been saying, Mike, how he made Effect all by himself. We had this long story about how Kit is the sole maker of Effect. But
yes,
that was
the
wild.
sole creator, but Michael is the soul keeper. He's the soul eater.
Yes, right. Yes.
The other term.
He said Mike just does, like, I don't know, something with like GitHub pull requests. He clicks merge and stuff like that. That's it. So that makes sense. Yeah.
Yeah. He's the bug bot guy. Not bug bot. Anyway. Yeah. So I forget where I am and what I'm saying, but that's kind of my road to Effect is through this very twisted, and I saw Pocock post about it, and I was like, holy shit, this is gonna blow. or has the potential to blow. And then I realized, oh my God, I love effect systems, and we'll talk about that in a
Yeah.
moment, what they are, why they are so cool. And I'm like, oh, there's a hope. There's still hope for what I've been working on for the last 4 years, except it's just I have to move to this parallel universe. I have to
Yep.
give up my old life and say goodbye to everyone I've ever loved and known, and embrace Michael and and uh, and Maxwell and all these other people who happen to be incredibly lovely. Like one of the benefits of working in a bigger pond is that you just have more people, which means
Yes.
more cool people and more energy and more excitement. And it's not everyone kind of just sort of eating their rations, poking their last lizard head on a rock and trying to eat. I'll eat the
We
ear
have
today
30
and the
people
tongue
at this
tomorrow.
conference and 7 of them don't like me. And you're like, okay, like there exists other people in the world. Like it's a big world.
Yes.
Yeah.
Yes. And that has its own benefits from anyway. And there's the whole
Yes.
like total addressable market thing from the business side of things,
Yeah.
which I don't.
They love it
tended
when
to
you say
ignore. That's
TAM.
why.
Yeah, we got a
Damn.
huge TAM, guys.
My secretary Tam.
Yeah.
She's huge. I don't know. Okay. Anyway, TOS. So yeah, it's good to be here. I would like to tell you about Effect and convince you of it. And I've prepared some slides.
Sweet.
The end.
Let's do the slides then
Do you want-
first, and then here, I'll open up the slides without leaking the password.
Perfect.
Because
Maybe it'll have remembered.
I do remember.
HTTP off.
Yes, yeah, I know. The yes, typing the password in is always dangerous on stream. They'll try and guess.
Especially because it's not. Well, I won't give any hints.
Oh, that's right. Here we go.
I'm sure no one will in your chat will try to just
It is it was good. I laughed
slides.
when I saw it though. Here. It's admin. Oh, did I say that out loud? Oh.
No. That was just you're just.
I muted myself, right? All right, here we go. Let me move my chats back now, and boom, there we go. We're live.
Okay.
Yes, and I can make this big
so I'm looking
too.
at your screen. Yeah, you want to make it a little bigger, but not too big for. But depending, I think that's a good size.
Yeah.
Some of the examples get a little long, so. I am able to control, as you know, the slides from my screen,
which is
we're
very
sort of web
cool.
socketing in here. This is a full stack effect application. It's very beautiful code base. I threw this together over the last 3 days. Yeah, I basically scraped together a whole bunch of different things. I'll post some things in the chat. There's this website I made a while ago called effect.kitlangton.com. Wow. Which just has some of these examples we're going to go through first.
Yeah.
So you can check that out later if you want to play with it yourself. But I've sort of turned it into this slideshow format where we can go through some different topics. So at the beginning, I just want to kind of tempt you with some pretty colors, if nothing else. And then we can sort of, feel free to ask me any questions at any point. We can talk about what an effect system is, all of its benefits, really anything. I mean, it's your stream. I guess I'm in charge, you said, but
you're in charge.
I'll let you be.
I'll say a good demo goes a long way. Twitch chat really likes pretty colors. That's good. I need to move my curtain really quick because the light is coming through. I hate the outdoor sun. I can't stand it. It burns my skin. Me and Mike are both vampires.
I understand. See, look, he's not there, and yet I can change the slide just to prove to everyone. I can make this go. Hello.
Yes. Okay, there we go. Okay, nice. My skin's no longer burning. I can focus.
Okay, I saw the steam was hard to ignore. Okay.
Yeah. All right, I'm ready.
Sweet.
Effect.effect.
I want to do.
I'm ready.
Yes, effect.effect. Yes. So a couple of things, and I think it's worth right off of the bat, immediately off of the bat, sort of addressing.
Is that a vampire joke? How dare you?
Yes, it was. It was
my culture is not your costume, Kit. Okay.
My culture is not your kit. Yes, whatever. So yes. So the effect.effect. Let's. We were talking. I think we understand psychically. We've both been bitten by Arnaldi, and we have a sort of a telekinetic mind speech.
Yes.
So, but we should enlighten the audience who haven't been thusly anointed.
Yep.
Which is effect has some syntactic overhead.
True.
It is a compromise with TypeScript. We wish to reap TypeScript's universality, its corporate investments via the metas of the world, its tooling, its 3 VC-backed runtimes.
Yes,
No other
exactly.
language has multiple competing VC backed. It has no other language has any VC backed runtimes.
True. Good point.
Um, which has its downsides, I'm sure. It's a little chaotic. Everyone knows this about JavaScript, but it also has immense benefits.
Mm-hmm.
People are trying to make things better all the time and destroy each other with their better things. Um, so it's a little violent and internecine, but it is nonetheless cool. And when you work in a language whose build system is slow and sucks and has no hope of it being improved, you start to look at TypeScript and get a little jealous.
You don't want to
So
type any more SBT files?
I'm sort of done with that. I
Okay.
mean, yeah, I
Got
would like to never see SVT again.
it.
Um, but anyway, um, so TypeScript is also has a very powerful type system. Only a few languages in the world could facilitate what is needed for something like an effect, or
True.
what Zio was in Scala. Zio can do it. Sorry, Scala can do it. TypeScript can do it. Maybe some other languages might be able to hack something in, but there are particular features of the language that you need in order to get all the powers that we're going for here, to get the level of type inference that we want.
Yes.
Um, so I'm not even sure. I mean, I'm sure there are a couple other ones, but TypeScript can do it theoretically, even if it has some downsides. And we'll talk about those. One of which is there's some syntactic overhead.
Yeah.
Obviously, the effect. The module system in TypeScript is not ideal. In other languages, like why couldn't it just be a type? Why couldn't it just be effect string instead of effect.effect string? There are reasons. There are good reasons
Yes.
for bundle size and tree shaking
Guys,
and all
you're
sorts of
gonna press
implementation details.
tab anyways and let the autocomplete do it anyways. You're just gonna you start typing :E and it's gonna do effect.effect. Relax. You're okay.
I made the green thing
I
occur.
like that though. That's cool.
I'm shaking the keys over people now we're talking too much about syntax, but don't worry, we'll get to some pretty colors in a moment. Um, so yeah, effect. Ugly. As long as it's consistent. My view with syntax is if it's consistent and you don't have to write it, which is increasingly true with LLMs.
Yes.
Your brain eventually learns to pattern match and it becomes noise. In an ideal world, we could fix it maybe in TypeScript. I don't even know what TypeScript version we're on now. In TypeScript 48, perhaps we can just delete one of these. Or AIs will take over, and we're never going to look at source code. We're going to look at some projection over it.
There we
So
go.
whatever, it can look like any language. You can be writing TypeScript, and it'll look like OCaml to you, like
Now
what the
we're
Unison
thinking.
people do.
Yes,
There
I
we
can
go.
already do that because OCaml can compile to it. Wait, we'll get to
Well, there you go.
No, all right.
We'll
I'm
get there.
with
That's
you.
the
I'm
later
with you.
slide.
Yes. This doesn't bother me at
Um,
all. For some people, I guess like
okay.
they're really mad. They have to type two things.
Some people are. I'm not looking at the chat, so let me know.
No,
You
no.
translate the
Everyone
chat
in
to me.
chat is saying Pog vampires. They're doing
Okay,
Team
good.
Edward versus Team Jacob. They've been distracted for 30 minutes on the werewolf vampire distinctions.
Perfect. We'll
For
just let
me,
this osmose in it.
yeah. For me, this doesn't bother me at all. It's like I have to type a module, so it makes sense. That's fine. It's TypeScript. And then I have things inside of it. Some things are types, some things are functions. That's not a big deal. You could just import everything inside of here, but then I feel like I don't like import star, and I also don't want to have 10,000 imports at the top of the file. So this is like,
Yes.
okay, it's chill. That's not a big deal.
Yeah, generally the way it works is for the types, it's going to be the module name dot the module name. So you're
Right.
going to get that that stuttered type definition. And for everything else, for constructors or for sort of free functions that modify something, we'll see what those look like in a moment. Later on, it's just going to be nested on that module.
Yeah, that makes sense
So
to
something
me.
like this.
Yep.
But there are other slides where you'll see there's some other syntactic overhead, and we'll address it. But nonetheless, so far so good. So yeah, this is a constructor.
Let me say one other thing.
Colors.
Let me say one other thing. If JavaScript had macros, it would be a worse language because people would have already abused it so much that we would have all been really sad. So every time you give TypeScript a feature, someone uses it the wrong way, guys, okay? So if you're mad that you have to type extra stuff, just be thankful you're not reading someone else's TypeScript macros. There you go. That's the way that you can think about it, okay? If they had used the feature, someone would have already used it bad and would have made your life bad and taken production down. So there you go.
Thank you for defending the
Yes.
verbosity. I'll take it, even though I'm a fan of macros in Scala. But
Well, me
maybe
too.
not
I like
with
my
the
own
show.
macros. It's just everyone else's suck.
Yes, that's so true. That's so true. No, I appreciate the steadfastness of the TypeScript team, that they're sticking to their principles. And it's nice to have principles. It's nice to see somebody having principles and stick to them.
Yeah.
Whether or not it, who knows if there's better ways of doing things. But okay, so that's how there are multiple ways of constructing an effect. This is a success effect. So we'll talk about effects. They represent computations, some sort or another. Computations, as we know, can succeed. Yay, the happy path.
True.
They can also explode. They can fail. We'll get to that in a moment. So this is how you would construct a simple effect with sort of a constant value, a literal value. So we're just kind of like future.successful or whatever it is.
Yep.
And then you have to run your effects. So we're going to get to this later on, but an effect is just a description. You can't just extract the value. You have to run it. It's a blueprint.
Yes, we don't
what's a
do
blueprint?
union types all over the place everywhere. We have real types. We have real types.
We have real types.
Yes.
But yes, an effect is basically a blueprint or a workflow. You'll hear this. If you're familiar with laziness, it's lazy.
Nice.
We'll get to that in
Twitch
more
chat
detail.
will like it then.
Yes, exactly. You're lazy, effects lazy. Let's go. Yeah. So what is if you a quick metaphor for laziness is any function is lazy, right? Functions don't run until you give them the parentheses at the end. You give them their
arguments in there.
You got to put the arguments in, otherwise it gets angry. But you got to feed it with its little sideways mouth thing. But if it has no arguments, you could just do the mouth.
Yeah.
And so on and so forth. So with effects, you don't call them because they're not functions, but they behave like functions, and you have to explicitly evaluate them or run them. And there's effect.run promise, which takes an effect and will turn it into a promise. So if you have an effect of a string, this will get you a promise of a string, and it'll of course kick it off right away.
That makes sense.
Because promises are eager and kick off right away. And we'll get into that later too. So yay, I'm running the effect when I press this button, and I can reset it and so on. And it evaluates immediately because it's just succeeding right away. Now, you can also have an effect that fails. And this is also type safe. This is one of the big distinctions with effect, is that tracking errors is super nice to do.
Errors as values? Important. What are we, Golang? There we go. See, there's your clickbait title now.
Effect is Golang.
Effect is Golang? Oh no, that's the I'm sure that's the most surefire way to make Mike mad. I don't know Mike that well, but
I think that makes everyone mad. Yeah, that makes no one happy. So that's good for views. So yeah, that's the title. There we go. Just get that gopher in there. And yeah. Every time I think of the Go-Gopher now, I think of it being pregnant with Bun, because I'm pretty sure Bun has just been cursing my nightmares with its weird.
That's living rent-free in everyone's mind, unfortunately. Mike, great April Fool's joke. Can you release the new version of Effect and it's all just if air not equal nil? All right. Anyway, sorry. Continue. So, I'm getting us too railed. Yeah.
Does the stream hear the fancy loud sound effects? I'm not sure if that gets piped into.
Do it again.
Into the machine.
Yeah, they can hear it now. I turned it up.
Okay, cool. So yay. Now you hear a happy sound. Now there's a kaboom sound. Okay.
Kaboom.
So there's obviously this visual representation here that's just to sell, to sell to the kids. But
to sell. Can we get a Subway Surfers in this? Sound effects. Holy cow! Good point, Ryan. Sound effects.
There is a bit of a pun there.
Yeah.
When your library is called effect, you just can't. It's impossible to avoid.
Yeah.
Puns. We try to not acknowledge them at this point.
No need to encourage them. I'm with you. Yep.
No. So I'm sure I will do accidentally many puns. I mean, feel free to track it in the chat.
Okay. That's a good point. That's a good point.
If that makes you happy, you got to throw the bone.
Okay, I get this.
You gotta throw
argument number 1, it's our return value. Argument number 2, it's our error value. We don't throw here. That's for losers. We return errors.
Exactly. The error is a value, and you're absolutely correct. Very astute, Teej. In the first example, the string there, the first type argument represents the success value. And there is another type argument, but it defaults to never, which means that that's not going to happen.
We don't do that.
So when we fail, it never succeeds. And we know that at the type level that if you probably don't want to call this effect because it's never going to do anything you want. It's always going to fail with kaboom error here.
Right.
And we see that when we run the program. Now, it is useful sometimes to explicitly fail, but usually you're going to combine this into a larger effect. You're going to build a larger effect that might succeed or might fail.
Good thing they're lazy because we can combine them.
Exactly.
Yeah.
Now, of course, because this is TypeScript, it's not Haskell. we don't have complete control of what the user does. So it is possible that things will maybe explode and you have no control over it. And at any point in your code, I could have done, say, effect.succeed and thrown an error in here or something like this. We can't stop the user from doing that as much as we'd like to. As much as Michael Arnaldi is going to be on the lookout for you, we can't technically legally stop you there at this point. So there's a third sort of failure mode, or a second failure mode. You have these tracked errors, and then you have defects. Ooh, spooky.
Oh, I like that
satisfying. Oh,
that's nice.
So technically, things can die. And this is a bit of a nuanced thing, but sometimes you want to track the errors that you care about, essentially. So these are expected errors, things that you might be able to recover from later, errors you might want to, domain errors you might want to be able to map into HTTP status codes or messages, right? So if you track all of your errors at the top of your application, you can map over those errors and convert them into HTTP status codes and messages, which is very useful. That's what Dylan Mulroy did on the new Vercel domain search thing, and he gave a talk about that. And
very
fast,
have
very
Dylan
cool. Back to talk about this because he's a more practiced streamer than I.
This is going great. You're doing awesome.
Okay. Thank you. I'm trying to shut down my brain as much as possible and reallocate to my mouth.
Great.
Okay.
Closer and closer to Dylan then.
Yes, be Dylan. I have his photo posted above here, so I'll just look at that and speak. Okay, cool. So another constructor for us. So this is the die one. Don't worry about it, except it looks pretty. So if you're confused, just focus on the colors.
This is panic in Rust. This is, okay, had something happen. I don't care. We're not going to handle this scenario. You ran out of disk space on your computer. You're stupid. Stop trying to do this. I'm done with you.
Thank you. Yes. And there are ways of recovering from these later on. In effect, there's a different sort of hierarchy of error handling that if you do want to try to catch these defects, and you can, like if you have an HTTP server and someone does do something stupid, and they don't track the error, it doesn't mean your whole server is going to go down.
Right.
It means the HTTP server is going to close out that request and can even log it however it wants. But basically it means that you don't have to deal with the error plumbing at that point because it's something that you really can't deal with at any point. Okay. But great analogy for those who know Rust. Yes, it's like panic, and this is like sort of the result type. Except the interesting thing about effect is that it kind of combines this IO type, which we'll look at in a second, with a result, and it smushes it together, and you get really. It's result plus plus.
Yeah,
absolutely. So here is another effect constructor called sync, and so as you see, every time I run this, we get a different random number or whatever JavaScript's version of a number. So a number between 0 and 1.
Yeah.
A float in any other language. So what sync does is you have to construct here a function thunk, a little function value. And so this traps the function inside of the effect, right? It's a blueprint. And so whenever you actually execute this, it will run that function, a different one every time. Versus the succeed constructor, you do not wrap it in a function. And JavaScript can't do any sort of secret implicit wrapping. So this will always be the same hello effect every time. If I called math random in here, it would do it evaluate that once.
And then stay the same.
Exactly.
Got it.
So
if we did it, I could still run effect.run promise on it a bunch of times, but it would always return the same thing. For the sync one, it'll call math random every time. It recalls the function.
Precisely. So this is for some synchronous side effecting code that might change. And maybe if you're confused about the nuances there, just always use sync and it'll do you right, whatever. It's TypeScript after all, it's not Rust. You're going to save yourself a function call overhead. But not such a big deal. I hear a buzzer. I might need to get that, but we'll see if it continues for more than a minute. Am I getting messages? No. Okay. We'll see. Okay, I'll bring up. So and here, is it getting wrapped? No, cool. The screen size is great. Perfect. So as you can see, now we are calling a little weather API here, a fake weather API nonetheless, but it's doing what it would do if this were a real weather API. And we're wrapping promises. So you can convert promises into effects. Obviously, we want to be able to eat up the whole world and take over. That's our master plan.
Yes, that's how TypeScript
and then charge you. Exactly. Once your whole code base is in effect, we'll charge you per effect evaluation.
Oh, very smart microtransactions.
That's the business plan.
I love that.
Yeah, microtransaction-based runtime.
Well, it's only the ones that succeed. So it's like make people feel like they're getting a deal on the errors.
That's true. We're going to have all sorts of plans going on.
All sorts of plans.
So yeah, this is what's it doing? it is, we're just wrapping a promise. So it's basically just like sync, except it expects to see a promise. And as you see, it cannot fail. There's a separate constructor called promise promise or promise try that will fail with sort of an unknown exception. Because as you know, promises can fail for any godforsaken reason, and it is not reflected in the type.
For sure.
And so if you want to, if this were to fail, it would be a die. So most of the time you're going to do try promise, and there's ways of sort of extracting a more reasonable error from this. But this is sort of just an example saying you can wrap a promise. And this one is taking some time to execute, as you can see.
Yep, makes sense.
And then our last constructor here that we're going to look at is just sleep. Effect.sleep, 2
Finally,
seconds.
the generators, the things people are really angry about because they're stars, and those aren't allowed in programming languages.
Yes, well, and so yes, this is the next bit of syntactic overhead that is not so ideal. And we'll get to that in just one moment. First, just to explain what's happening is that it's sleeping for 2 seconds and then it's returning the string refreshed. So this is
that is not enough time for
asynchronous.
me to sleep to feel refreshed. I just want you to know. I usually have to sleep at least 6 hours.
You'll get there. I mean, if you're polyphasic sleep, really like micro
2-second nap, polyphasic.
Yeah,
sleep.
time sharing. Like the
it's like the guy who said he was sleeping to get his Claude refreshed. I'm polyphasic sleeping to wait for Claude to finish typing each individual prompt. If you're not maxing every prompt response time, you're missing out. You're not even close to grinding like me.
Yeah, and if you need to catch up, just ask it to throw some ultra thinks in there, and then just get a little bit of a 10 more seconds on the clock. Let me quickly jump over to one of these other millions of things, generator syntax. Yay, this is fun.
Nice.
Is that working?
Looks cool. Yeah, that looks great.
That's pretty.
Yeah, I love this.
So obviously this is async await syntax. This is not effect. This is what the equivalent of effect would be in promise world. And I'm going to go back and forth here a few times.
It's the
to
same.
Let your brain
you didn't put like the corporate it's the same meme needs to come in on the slides right here, like, you know what I'm saying?
I didn't have time to do a meme pass of these slides over the last couple of days. I really should have, and I feel bad now.
Yeah,
but that's your job. You are our living meme.
There you go. I've already thought of a few, but this one is the corporate spot the difference one. They're the same. That's the thing you need. It's the same picture. Yep.
So we'll spot the difference. And of course, the difference is this is more verbose and it's not using the async await syntax. And there's like some redundancy because you have effect.fn and you have this function start thing.
I guess,
that these are generator functions in TypeScript. Do you have to know how generator functions work? No. All you need to know is the semantics, which is the same semantics as async await.
It looks
which is that it's basic.
I'm not just like blowing smoke for effect or anything. Like, it looks literally the same. Like, it's exactly the same, guys. I don't know what to tell you.
It used to look worse. Back, I think I watched in preparation for this. I know you are a known associate of the primary agent.
Yeah, I am.
So the
did Prime look at one early on and then be like, I hate this, I'm done?
2 years ago, we had to delete the repo. He gave it a thumbs down.
Oh man, the very first version of open source Gladiator.
We had to. Yeah, exactly. We had to start again, but we did it better. We learned. And so in this time, I'm not going to show you what there was like this other, I don't know, they figured out how to do it. This was before I was doing TypeScript. There was like some $sign argument and you had to wrap the subcalls. It looked ugly.
Yeah.
Now it looks really good compared to what it was. Yes, it would be great if TypeScript let us sort of hook into async await syntax with our own custom types, but they don't. So they figured out a really clever way of getting the same semantics with just a little more boilerplate.
Yeah, this looks literally like this is. Yeah, it doesn't bother me at all. This part doesn't bother me at all.
So this one's getting crushed a little bit because of you might need to just bob it down just one for this slide. And here I add types, and so it's a function to promise, and this one's a function to effect. So there's effect.fn constructor. So there's two constructors. There's effect.gen, which is if you don't take any arguments, but if you want to sort of get a more concise function that takes arguments, you can use effect.fn, and then in your generator function, give it an argument. So if you're confused by what that means, like just know that these are the same again. These are the same. So effect.fn takes an argument, and this gets you back a function that'll take a user ID and return an effect. whereas the other one takes the user ID and returns a promise. So same exact deal.
And
now
that's
with
got
that,
got void, not never, because it's not that it doesn't finish, it's that it doesn't return anything. Those are different things.
Exactly. And if people are new to that aspect of the types, because I don't know if that comes up for people all the time with TypeScript. We definitely use the TypeScript type system to the max internally, and there are probably a little more on the surface level APIs than other libraries. So never is a type that's uninhabited, which is a fancy category theory term, I guess. Nice. To say that there are no values of that type. Like, quick type theory lesson. All a type is, it's like it's a box. It's a label on a box, and inside of the box are all the different values that could be in that under that type.
Yes.
So Boolean is a box with the label Boolean. There's no Boolean value. You can't have, I have Boolean.
Can't.
You have either true or false. So in the Boolean box, you have true or false. And Boolean is sort of just the union of all those possible types.
Yeah.
So never is a box that says never on it. And in the box,
it's empty.
Is, can I
curse? You go for it. Yeah.
Can I do something really just vicious that'll make everyone leave? No, I'm kidding. Never mind. I was gonna say there's nothing. There's jack shit in the box. Wow. I'm not gonna.
That would be something, though. That would be something.
Well, jack shit. The emoji is there's no such thing as a jackrabbit. It's apocryphal. It's a cryptozoological construct. So shit would be non-existent.
Is that how that happened?
I'm not sure if that's true.
Okay. Anyways.
Anyway, enough of my filthy mind. And that was not a very big curse. I was just checking to see if I could curse at all. I didn't want to get people excited that I was going to do some crazy curse there. Just so for the future now I can throw in words like poo and such.
That's for sure
so cool.
allowed,
So there's nothing in the never box. And in the void is a type with one inhabitant, which is just a little nothingness. It's just kind of like a sigil value. It's just the remnant, smoldering remains of something happened.
Yeah.
But if you only have one value, you can't do anything with that. Like, it's like grunting. Yep. Like if you ask Zug, what do you want for breakfast? Do you want a breakfast burrito or do you want bacon? If Zug can only say Zug, then he cannot communicate to you the choice. There's no binary decision. You need at least sort of two options to communicate anything meaningful. That's why sort of Boolean is the simplest type with of use. Yeah. And void is just kind of a grunt, a useless, fruitless grunt into the void. Okay. Anyway, I'm sure that made a lot of sense. So let's take a pause here. I mean, what thoughts are rushing through your spine?
These parts I already knew. I've already read a little bit of the docs. I always come prepared. I don't want to, I didn't come up with everything that I said all by myself. I've read a little bit for it. I even know we're gonna put some dependency things in the third argument. I'm already way ahead of this, the schedule here. Chat knows me. I come with reading. This was mostly for chat so they can get this far. Nothing you've said so far bothers me. This all seems super normal. You gotta encode the stuff. You gotta use what the language features got. Do you want to type yield to say, here, it's time for someone else to run some code? That's fine. It doesn't have OCaml's cool OCaml 5 effects where it can preemptively resume and do, other things with execution. That's fine. But so you just got to do what you got to do. That doesn't really bother me. So nothing so far really freaks me out or makes me think I wouldn't want to do effects.
Okay, cool. Yeah. Well, then I want to get you even more juiced about effect. I'm not sure if
let's
that's the phrase, but I want to juice you up. So some more pretty colors. I think everyone likes the pretty colors in a sequence because those are one at a time. Now we're going to talk about concurrency.
Love that.
So here is effect.all.
Much like Bitcoin or like what kind of concurrency do you usually use?
Yeah, did someone say that in chat?
No, it's just sorry, I couldn't resist. Man, concurrency. Go ahead.
Concurrency. Yeah, I'm trying to remain human. Focusing too hard on the slides and being slightly sleep deprived, I might sort of miss some zingers. So feel free to slap me back into.
No, you're good. We're good. We can go fast.
Command me to chuckle, and I will chuckle. So yes, we're reading a bunch of temperatures. One might imagine that each of these returns an effect of a number. Let's say the temperature in Fahrenheit.
Mm-hmm.
Fahrenheit supremacy, anthropocentric, their measurements.
Numbers are for people.
And so numbers are for people.
Very cool.
So yeah, and it gets a little crunch there. Oops, that's my fault, not your fault. There's no size that will fix that. I just, it happens here. Not on that effect.kitlangton.website.
That's
Nothing will fix this. It was my fault. So yay. So we can see that they're executing in order and then returning a result, which is an array of all those values. So just like promise.all, except not in parallel.
Right.
And the whole reason why like promise.all returns them in parallel is because when you construct a promise, it's eager, it kicks off right away. So promise.all couldn't not have it run in parallel unless promise.all accepted functions that return promises would be the only way it could possibly manage that.
Makes sense.
So with effect, you have some flexibility.
Yep.
So by default, they run sequentially. However, there's an options list. Nice. And you can specify the concurrency level. So with concurrency 2, let me just run it so you can get a sense of what's happening. Pay close attention. We'll do it a couple times.
Nice. Does it always take them from the start to the end? Is it like 2?
Yes, I think it does. Okay. Yeah. I mean, this is actually running effect in the browser. So yeah, this is what is happening.
Yeah.
Now, and it's 2, not in a sliding window of 2 at a time, but there's always 2 running. So if one finishes first, you'll see that it's sort of like a semaphore with 2 whatever claims.
Gotcha.
Yeah.
Yep.
So there's a little bit of overlap, and you can see in the logs if you scroll through the logs exactly that it's like starts 2, one finishes, it starts the next one.
Yep.
And so on and so forth.
Yep.
So that's pretty cool. And then if you just want to go full on maximum parallelism and bring down all your API friends servers,
run them all.
Boom. Unbounded, and that makes a nice little moody chord there.
That's nice.
So I'll do that a couple times to tempt you, everyone.
Yeah.
Cool. So I mean,
that totally makes sense.
That's effect.
Effect.all. That's the one you always would use, and then there's options that changes how we would potentially do it concurrency. I'm just, you know what I'm saying? Like this kind of like this idea of we're looking for patterns in effect. It's like we have this function, then we change kind of like its runtime behavior by passing different options instead of having like run all concurrent. Effect.all unbounded. It's like we're mostly going to do this more with like things passed into the function, or we'll just see.
So instead of it's like instead of having an alternate effect.all unbounded effect.all concurrency or whatever, this option list final parameter is used. It's a pattern that exists. Sometimes there are variants, of course. But you will see this as well, just to sort of, there's already enough clutter in effect dot because it has all the constructors and all the modifiers. This is one way of reducing option overload and autocomplete overload.
Cool.
I'm guessing.
Yep.
And so now this is really important, and we're going to look at another example all about this, but racing and structured concurrency. There's a whole slide here about structured concurrency, which is super powerful and which promises completely lack. And I think one of the things that where people look at effect and they're saying, like the other day on Twitter, someone's like, effect is just like low dash. Like, I don't even know what that means. I don't even know how that means. It's a library for TypeScript. You import it.
Okay.
It is not.
We need to start importing effect as just an underscore.
Maybe.
And then that'll really get the people mad.
That's a good idea. Well, Michael's, I think, listening. I'm still too afraid to look at my Discord. Okay, cool.
Yep.
Underscore. So cool. So anyway, it's not like Lodash. It's people compared to RxJS. RxJS has its own stuff going on. It's a different paradigm. It's everything is a stream. I don't think that's the greatest abstraction for programs. And there's other issues with it. We can talk about that later on. But promises, which is what most people use, suck jack shit. They suck nothing, I guess, based on what I said earlier.
Got 'em.
They stink.
Get wrecked.
They're not good. And it's subtle. You don't tend to run into these issues of not having structured concurrency in simple programs. We'll look at an example where it does matter. Increasingly, with AI workflows and agents running in the AI cloud.
Oh, nice. Announcing effects VC raise.
Announcing now. I'm just going to pivot into that, completely take over. Get out of the shot, Teej.
Exactly. And now it's time for the big announcement.
Oh, no, I spilled my juice. I spilled my orange juice. Luckily, it was mostly finished.
Close one.
Okay, you're a professional streamer. Should one drink orange juice? I asked the LLMs before streaming.
It's safe.
Like it'll make your mouth spitty.
Oh, I thought you meant, are we concerned that people will say that you're a racist? Because we found out 2 years ago that milk was racist. and everyone got really mad that we had milk. And so we said, too bad. We think milk tastes good and racists are dumb. That didn't stop everybody. But
I would like to turn to the camera. I'm so sorry. I didn't realize these were milk drinking.
yeah.
Subhuman milk drinkers. I've got to end this. I'm going to close
Unknown
this
milk
out
drinking.
right now. Wow.
Yeah.
So that's hilarious. Okay, I didn't think to look at. You're right. I shouldn't even worry about anything. Never mind.
No, you're 100%. You're good.
I was more worried about biological consequences.
Yeah,
but
I
you're
thought
right.
you meant like.
There are other things to worry about.
Is
Has
milk?
orange juice ever done anything bad?
Well,
public?
okay. I have a
What
funny
is it?
story related to that. That is actually something. Is there? So my wife and I are going on our first cruise coming up soon for our 10-year anniversary. So just me and her, first time we've gone on a trip
Alright.
by ourselves in a while. We got 3 little kids. And she was like, "Okay, I found out something. We cannot wear pineapples on the cruise ship." I said, "You're right. I'm glad that you know that because I have a shirt that's got pineapples all over it. We are not bringing that one on the cruise. We have to make sure that that's a no-go." So sometimes symbolism does matter. That's all I'm saying is sometimes.
Yeah, my wife got me a pineapple necklace a long time ago, even from Burning Man, which is where she acquired it, and I didn't know what its alternate. I
At
don't think
Burning
she
Man,
knew.
it for sure
She
means
didn't
that
know
too. I
either.
feel like.
It might. It also means hospitality, man. I think it kind of got
Okay.
memed from
Yeah.
the internet into a thing. But now, certainly, I do wonder, just having worn that for a couple of years, thinking it's the only necklace I have. And
Yeah.
necklaces are cool. It's a shiny pineapple. It's very subtle.
Yes.
But no, it's probably sending all sorts of weird
So,
signals.
chat, if you don't know, just this will save you from a very awkward situation at some point if you don't know. Pineapple on pizza is still allowed. You just don't want to wear a pineapple shirt, put pineapple on something. Just means you're kind of like down to clown with other people, okay? So just like keep that in mind. Pineapple on pizza is good
Indeed.
though. Yeah. Continuing on, so orange. That's what it made me think of though when you said that. Is it okay to do orange juice? Like, am I sending a sign? Am I throwing up the bat signal for anybody?
Yeah, what kind of bats for Michael?
Yeah.
No. All right. So,
anyways, go ahead. Continue.
So yeah,
So I
structured
didn't mean to
concurrency,
get
whatever.
there in the middle of this. Effect.race. Tell me more. Yeah.
Yes. So effect.race. It's a superhuman race of
Yes.
of people. Okay, let's run this. Boom. So yeah, you can see in the logs that they both start to race. They both of the effects kick off.
Yep.
One completes, and the other one is it's got this. It's orange, and there's a little bang on it.
Yes.
It gets interrupted. So whoever loses the race,
Yeah.
will get interrupted. If Tortoise wins, Achilles is interrupted. Wait a second. Why is Achilles a rabbit?
Because the tortoise and the
It's supposed
hare.
to be a man.
Right.
Yeah, it's mixed metaphors. I was going for the sort of Zeno's paradox thing,
Okay.
but whatever. It's got. I told LLMs to add the emojis, and it completely.
It was so locked in on tortoise and the hare that it did not listen to anything else you did. That's really funny.
Anyway, so
Yeah.
but the interruption is happening. So effect.race starts to affect. If one succeeds, it'll interrupt the other. It'll cancel it.
Yep.
No more.
Yep.
This does not happen with promises. With promise.all, we'll look at this. Actually, I can look at this right now.
Quick question on this one for race.
Yep.
If I have like a
Let me go back to
generator
race.
one, this will like I'm yielding, yield. Does it like, and I do a yield and I get canceled? I don't get resumed, or does something else happen? Does that make sense?
So so because effect is this sort of runtime inside of TypeScript,
Right.
it has an inner sort of work loop that will run these effects. And so when you have a generator function,
Yep.
the async await construct, right, and you have some
Yep.
sequential code, if that gets interrupted, it's going to sort of mark in that runtime that it's been interrupted, and it will just not execute the next
Nice,
effect.
very
so
cool.
it'll stop it there. There are ways of recovering from this. There's all sorts of ways of catching interruptions if you want to, but for the most part, it'll just cancel out, which is 99% of the time.
That's what you
want to happen.
Yes, please just stop sending the rest of the request and don't write it to the database, and we're all done, and I'm happy. Yeah.
Exactly, because I mean, with race in particular, like you want to race two things, so you might want to send the same LLM request to two different providers, and you just want the fastest one, so you don't care about the other one. Kill it. And especially once again with the age of LLMs and the AI cloud, it's important to not. It costs money, like more than ever. A request is expensive.
Yeah.
More than it ever was to like hit an API.
True.
Now it's going to cost real money. So with promises, promise.race is rather difficult to implement, and it doesn't work compositionally. Like if you use effect, it'll cancel everything that's going on in that sub effect. You don't have to thread some abort controller nonsense through your whole program and basically rewrite effect in your program. It'll just work. If you use the effect primitives, it'll just work for you.
That makes sense.
Another example here that I wanted to show for this one is, this is the next slide. We'll get to this in a minute, but for effect.all, it's the same as effect.all before. We have 3 different things running, except now they might fail. If one of the effects fails, well, I guess this isn't in parallel, so we're not going to really be able to see it. But anyway, I'll run this. It fails. It doesn't run, obviously, the remaining ones, because the whole point of effect.all is that you're going to get back all the results. Like it's useless to you if you just get back one of them. So it's going to stop running. If this were effect.all unbounded, which unfortunately I did not make an example for, it would have interrupted everything else. So if there's a failure, it'll interrupt the parallel processes, if that makes sense. Just like this. Okay, so it's effect.race. There's also effect.raceAll. So you can race a bunch of things, and it's kind of like effect.all, except the first one wins and the rest get interrupted. Cat. Oh, you have a cuter cat emoji than me. You must be in a different operating system.
Oh yeah, it's Omachi.
Yours looks derpy.
Yeah.
Oh, cool. Well, that's kind of the basics of concurrency.
That all makes sense.
What is chat saying? Is chat pissed off? Is chat really excited?
Oh, they're still talking about vampires.
Okay,
no, I'm just kidding. Dylan says, imagine TypeScript devs actually taking the time and care to properly weave abort controllers through their applications. Yes, that doesn't seem likely to me. The problem is, if something's easy to do, people will pick that. So there you go. So then you have to make it easy to do the right thing and hard to do the wrong thing. If it's easy to skip putting abort controllers throughout your whole project, people are going to skip it. That's what's going to happen. That's just what's going to happen.
No, absolutely. And that's what effect tries to do. Like if you use the defaults, you'll get the right behavior that you want. And these things don't come up in like toy scripts, because it doesn't matter if you leak resources in like a local script that it's like
a bunch of people's answer is, I'm doing serverless. I'm going to leak the resources on purpose. I don't care. We'll clean it up when it's done. And you're like, surely that can't always be the right answer though, guys.
And it depends. Like it really does depend. Like in the case of all, if you are hitting a bunch of LLMs, I don't know. Like if your program is more than just one level deep, you might be doing multiple things simultaneously. And if something was unneeded, you did promise.all with like 5 different sub-promises, sub-programs, and you keep going and doing something else, but that thing failed. Well, those other 4, which you're never going to use the results of, those entire 4 sub-promise trees, which could extend levels, 10 levels down, are all going to still be running, and there's nothing you can do about it.
Someone should tell 8sleep about this. Maybe then they wouldn't have to send 16 gigabytes of telemetry every month about what your bed is doing. Oh man.
Yeah. No, I mean honestly, like using, now that the web has like I don't know, the inshitification of software, now that I can use the word shit, the inshitification of software, the known meme of this, I think partly is because we're doing more concurrency. And I've noticed it, like, I don't know if you use, if you've heard of ChatGPT, but if you use that website, if you use other Claude,
is that kind of like Grok?
It's like AOL Instant Messenger, basically.
Got it. Yes. Okay.
But all the time on that website, especially when doing like long-running, thinking operations or image generation things, my chats just break and they don't show the responses, and they just kind of remain in this weird, inconsistent state forever. And I'm thinking like they're probably not using effect on the front end, and it's probably some kind of weird cancellation or retry issue where something dies and they just didn't thread in these abort controllers everywhere. They didn't propagate the errors back up. We'll look in a moment about how you have to do this with a promise, and it just sucks, and it's so verbose, and it's hard to get right anyway. Michael, I think, has a whole talk about this somewhere.
Yeah, let's see how bad promises are.
We'll get to that now, I think. So it's kind of, there's one more thing on error handling, but we can skip to the we can jump around. I mean, there's no real order. Let's talk about structured concurrency.
Okay.
So here's a little example, or a big example.
Load cart can fail, load shipping can fail. Boom. We're already screwed.
Exactly. These both can fail. We're in promise.all. It's a very simple example. Please elaborate towards, these are both very expensive LLM calls. You have 10 of them, whatever. But I didn't want to overwhelm this.
This is good. I think this is a good enough example. This is like you load 2 things on the page. You do that. But then sometimes one or both or none break. Now, how do you handle it? This doesn't handle any of that.
And it doesn't handle any of it, and also there's going to be wasted work as well. So
Yep.
and you don't know how these can fail. Like, so okay, let's go through. First, I'm going to run it as it is. So it loads checkout, it loads the cart, it loads the shipping option. This one succeeded.
Yep.
They both resolve after a time, and then we see that the checkout is ready. So I'll run that
Beautiful.
one more time.
Yep.
Yay. And we can see the implementations of load cart. It's going to log at the beginning. It's going to fetch some JSON. It's going to print that it loaded. Yeah, and it takes a couple seconds to run each of those. And they kick off in parallel.
Yep, makes sense.
So that's that. But the question is, yeah, what are the semantics of
Nobody
this?
knows. That's the answer.
What if this? What if this dies? So now load cart is going to fail after a time. Cart service is unavailable. Well, oh no, shipping options kept going.
Yep.
So yeah, this is uninterruptible.
Yes.
What do you think of the animations, chat? Pretty cool, huh? Pretty slick.
I think so. I really like it.
Thanks.
We're going to have to talk later about how you did this. I want to steal it and then use it for my own videos.
Yeah, no, totally. I will definitely open source this at some point. I've got to figure out the untangle the insanity that it is. So yeah, wasted work. Kind of what I was getting at, except now imagine this just charged you $100 because there's actually a subtree of like 50,000 LLM calls that were running for the next 10 minutes, and you couldn't stop it because you weren't using serverless. Anyway, so yeah, how do you solve this problem? If you did want to solve this problem, well, first you would create an abort controller.
Right.
That's sensible. And then what? How do you use this abort controller? Well, no problem. First, you have to take every function. Oh, can you make this font size just a little bigger? I should have.
Yep. No, you're good.
Just one. A little bigger. A little negative bigger.
Yep.
Cool. I think you can go up one more, if that works. Whatever the chat's happy with.
Yeah.
Because things will compress weirdly sometimes. Okay, cool. So yeah, you add a signal. Huh?
Yep.
Beautiful. And then in the body of it, you have to pass it to fetch now. So fetch is built with this abort controller. How convenient. They wrote the API to work with abort signals.
Web standards.
I mean, if you're not using an effect system like this, there's really no other way of doing this. Like the idea that effect is controlling everything and everything is evaluated once in its runtime, and it's all you're composing this giant workflow that doesn't run until you want it to run, allows it to do all of these cool things. So that isn't some arbitrary orthogonal feature. Like, it is the necessary foundation for getting everything else. And we'll see why it's nicer in a moment. So anyway, you have to create the abort controller, and then make every function that you need to be abortable accept an abort signal, and then you have to get the controller's abort signal.
Yeah.
But of course, that's not it, because the abort controller has to be told to abort in some circumstance. So you have to wrap this whole thing in a try catch and then explicitly call abort on your controller.
And then throw the same error. Got it. Yep. Right.
And then if you want to continue propagating the error, I'm rethrowing here. I could at this point catch it, but yeah, I'm rethrowing here. Cool. And then we can load the checkout. And I think you can make it a little bigger again too if you want. Just to keep an eye on when it sort of gets all smushy. So yeah, now it's working. Card service is unavailable, and it doesn't you don't see that the load shipping succeeds like it did a moment ago. Sad. Yeah, and all you had to do was add like 30 lines of code. And this isn't something you do once. You have to keep doing this every time you add another method.
This would be kind of hard. This would be kind of hard if we had to like use someone else's library that didn't have signals, abort signals that I can pass into it.
That is true too. Hopefully some third-party library would expose some way of canceling ongoing things, but yeah, not all of them do. Yeah. Of course. I think the Vercel's AI SDK does support this.
Oh yeah, I'm sure like libraries a lot of the big ones, but yes, right. Yeah.
And so anyway, so that's how you have to solve it if you don't want the shitty semantics.
Yes.
Which has huge consequences. It's not so bad here, but in the real world, pretty complicated.
Yes.
So now let's switch over to effect land. So once again, the transformation to using from async await to yielding an effect.fn. So just going to do that a couple more times. You can see that it's effect.gen at the bottom because the program itself doesn't need to accept a function. Yet always when you're defining a promise with async await syntax, it always gets you back a function to a promise.
Right.
Because if it just constructed a promise, it would kick it off right away because it's eager.
Yep. We need to be lazy.
So effect. Yes. With effect, because the effect itself is lazy, you don't need to wrap it in a promise, wrap it behind a function arrow if to prevent it from eagerly evaluating.
Yep.
So you really only wrap them in functions if they take arguments, which is sensible, I think.
Yep.
Otherwise, you're just descriptions. Okay, cool.
Mhm.
So the same thing so far. So how do you handle this? Well, first, this is the success case, but now with pretty shapes, because Effect is better. It has pretty rectangles and
I
squares
like that.
for
Yeah,
you.
that makes sense.
Promises don't have, interesting, no one ever
emojis.
talks about how Promises doesn't have squares.
It doesn't even have emojis. It's kind of embarrassing. No emoji
Yeah,
support
but
in 2025? Oh,
yeah, no
my
emoji
goodness.
support built into Promise, but Effects have shapes. So that's pretty cool. So that works. So now let's look at the implementations of this. So we're using, in this case, try promise.
Mhm.
We'll talk about this in a minute. So try promise, obviously we're wrapping effect. We're wrapping fetch here, which is not an effectful function.
Yep.
We're interoperating. You could also write this with effects built in HTTP client, and it would do the cancellation for you.
Right.
But because we didn't write effect, we can't just cancel. Because we didn't write fetch, we can't just cancel it. You still have to pass a signal into it. But try promise gives you the signal to use. You don't have to thread it throughout your whole program. You just have to wrap
Nice.
it
just
at the point where you interoperate.
Very cool. Mm-hmm.
And this will translate effects interruption to the outside world of promise. So with effect, you don't ever have to think about signals. This will just cancel. But if you want to interoperate, you do have to propagate this.
Yeah.
Secondly, there's a type here. You might need
I got it. I'm on it.
I'm so sorry.
No, you're good.
I'm so sorry. So if you use try promise, it will take, because this could throw.
Right.
It will, but you don't know what, because anything. There's this unknown exception, sort of catch-all.
Yep.
However, try promise also lets you catch that error and map it into a domain-specific error. So here I can make it into a cart error if I want to. Once again, a little verbose and ugly and cluttered here, but you do this once at the boundary. If you do this a lot with the same API, you can write some abstract helper and just wrap all the fetch calls with it, and you don't have to deal with this.
It doesn't seem that verbose. You have to write what you're going to do when you want to try and catch it. It seems like pretty much. So I'll say, from the limited stuff I've done looking at Effect, my impression is most of the people who complain about this version of Effect will leave aside complaints from 3 years ago. Is they say it's super verbose, but that's because they're not handling anything that you're handling. So then that's just cheating. Saying, well, my thing doesn't, mine doesn't do any of this. And you're like, yeah, I know, that's kind of the point.
Yes, and I mean, it is fair that, like, there's that Elixir model of, right, let it fail, let it die.
Yeah, well, Elixir knows how to restart itself and a bunch of other things.
Exactly. I mean, but maybe if you're using JavaScript in one of these, serverless environments, the server will just restart. Like, there are many paths to Rome, right? I think there's something to be said for that. But if you want a production backend that you understand what's happening and you don't just want to be like, whatever, we have enough engineers, we'll just open bug reports and it'll sort of evolve.
We have enough engineers. They're all 10x as productive.
Eventually, whatever, one of those diffusion models towards some kind of reasonable code base that we don't understand, but is some alien that's pointed in the right direction.
Right.
Like, okay, now I'm being negative again, but I get it. Like, the people generally are not trying to just be mean, and the syntax at first can be like, if I didn't sort of lather you up here in advance and lubricate us with these previous slides and animations, if you just sort of just wake up and this is blaring into your eyes, you're going to be like, what the effect sucks. This is nonsense.
I get that part. I'm just saying, like, when I say if I was to say some code is verbose, I would generally feel that means to mean it's saying more than it needs to do the thing, so that's like, but that's not the same thing, right? Like, I don't think Go, like, error handling is like verbose. It's repetitive, maybe. Sure. And there are some things about that I think are like dumb, like that you can shadow error inside of loops and then return the wrong error, things like this, right? But you're like, sure. But it's not really like verbose. It's just doing exactly what it says it's going to do. So anyways, it's just, right.
No, I shouldn't be so hard on Effect. You're right. It's the greatest library known to man. You sold me on it a little bit so far, I've got to say. So there's that function. We're dealing with that. So now that can fail with a cart error. And we're going to do the same thing with the shipping thing. Yep. Have a shipping error, whatever.
Now we've got two different errors. Our load checkout it returns a union of these two errors.
It does. I don't think I added the type. We'll look at that in another, because there's this
I don't need it. I see it. Example. Right. Me and TSC. Okay. We're right there. We're right there. Yeah.
what have I done? I've lost my step count. Okay, I did something to my server where it loses the step count between slides. I'm a fool. Okay. So automatic interruption. So now that we have that, we can see what happens. Now that we have that signal, so card service unavailable.
Nice.
It doesn't run the next one. And actually, this is the sequential version. Oh, so I do have an example because it just never ran load shipping because we didn't have unbounded. So what are the semantics? Well, this blows up and therefore this never runs. Whereas for this, I think you can bump the font size up a little bit. I'm sorry for being such a pest.
No, you're great.
I'm so controlling.
I'm typing back to Michael in chat. He keeps on messaging things about how great you're doing, and he thinks like nobody's ever been a better creator of effect than you, and things like that. So, yeah.
All right, so it's all downhill from here. Oh, that succeeded. Okay, sometimes it succeeds, obviously, because you know maybe the card service is available. So now it never runs. So if I change this to concurrency unbounded and try again, they both kick off, and the one that loses is uninterrupted. Now notice what's different about this is that we don't have to do anything at this level. The only interrupt moment where you had to see the word signal was when dealing with fetch,
right?
Because
outside
we don't control
of
that.
effect, bridging the gap between non-effect world and effect world makes sense at the boundary.
And the effect maintainers are incredibly good at building out sort of the infrastructure for everything and building effect versions, effect native versions of everything that you could possibly want that deal with that interrupt and have nice errors and also deal with that third parameter sometimes, which we can talk about later if we want to. But basically, it'll just work. And you don't have to make an abort controller, and you don't have to then signal the abort controller to abort, which is just awful, horrible nonsense. Like, if you're using one of these things and one fails, the semantics are that it'll interrupt. And there are other combinators too that do different things, which we can take a look at in another slide that I haven't shown here. But if you can let them all return and run and return as either's or some kind of result types. You get they'll all run to completion, and you'll get a list of results. Anyway. So that's the unbounded version. Boom.
Sweet.
And then there's also, what if you want to do something when it's interrupted?
Nice.
So you can say on interrupt and then give it something to do when it's been interrupted. And
good thing load shipping is lazy. Otherwise, we couldn't do this.
Exactly.
Yeah.
Exactly.
Makes sense.
So now we're going to see that, oops. Loading shipping. I must have deleted the log, actually. I'm a fool. So it should say shipping options interrupted, but I hacked something here. Anyway, you can hook into these life cycle events. Cool. And it doesn't have to be on the outside. That can be on any sort of part of load cart internally that wasn't yet executed. So maybe if you put it on just console log loading cart, it probably wouldn't run because that runs right away. But if you do it on like the one at the end, then that never ran, so that got interrupted. So then it would run the interrupt handler. So it's all composable, and you don't have to think about it. Okay, that's kind of structured concurrency, and this is like one little simple example.
No, that makes sense.
Yeah, I think I had an LLM sort of. I said, okay, do the same thing, but now with LLMs. And so we'll see how it did, copying my pattern here. But basically, like, it's the same exact thing, promise.all, except it's these three, one might imagine, expensive LLM calls that cost you, $270 altogether.
Right.
And then what if one of them fails?
Wait, how did you find my script for writing my blog?
So we can see that rate limit exceeded for the first one, but of course the first two. So same exact structure, except now there's dollars. And now you can imagine yourself being fired and now wanting to run towards effect, where it does, it's just all effectful stuff now. We don't interoperate with fetch. And I'm not using, this is not the right example. Here's the
Does Dylan still make fun of Datadog? Can we say like the other ones have Datadog queries inside of them? Dylan, wasn't that one of your favorite pastimes? I don't remember if that was one of your favorite pastimes. Am I getting that mixed up with somebody? I don't know if you're out there still.
I've got to get into Datadog. I feel like I'm missing it.
Okay. That's right. Yeah, okay. That wasn't you. Yeah, that's right. It was Reese. Okay, yeah, it was Reese. My bad. We were talking about it at SquiggleConf. SquiggleConf, great conference, by the way, chat. You guys should look for SquiggleConf 2027.
2027?
They're moving to springtime, so it's a year and a half between them. So it'll be early 2027 is the next one.
Oh, okay. I was like, oh, damn, man, we're in the future.
We're in the future. We're living in the future. He got that data dog in him. All right. Anyways, I'm watching. I get this. This all makes sense. We can skip this one. I got you.
It's just another example of the same thing. It automatically interrupts, so we're not being. It's free. Effect is cheaper. You can't afford not to use Effect. Is the point? Okay.
Oh, I love that. There we go. Nice. Okay.
There you go.
Yep.
That's that. So, I have more examples for you to talk about other concepts. Error tracking. There's like a little more example here.
Yep.
But we could take a break too, or pause, or like just step back and assess and meditate.
I'm good. We can keep going. I'm following everything you're saying so far. I like.
Okay.
This is good. This is good for me.
I'll try to throw you. Actually, this one might be slightly simpler. So
I'll guess. Let me guess. We're going to show here each of these can fail. Right now, we don't know. One, we don't know that both of them can fail. Then number two, we don't know how they can fail. So both of those are getting untracked. So when I call this function later, I'm just like, bro, get me the deposits, acquire the riches, give me the deposits, whatever. I got two different kinds of failures. We need to track all those. So let's put it in the second column.
I'm done. Hit the button. You can press it too.
Oh, I can.
Press it.
What? Oh, right here. Oh, nice. Oh, account overflow. Yeah, that makes relatable. I have this all the time with my bank. I have to keep calling them, guys. It's the OCaml checks coming in. The OCaml checks. They don't believe it. Okay, I got. Yep, this makes sense.
Yeah,
yep.
You totally get it. So looking at the code, and here's another way. Guess what?
Sometimes.
God.
No. Pirates of the Caribbean 1 kind of scenario.
Exactly.
Just watched
and
that
then even
movie
again
recently. Great movie.
You get the riches. You go to celebrate.
Oh
and
no.
Then,
Oh no. Vanity of vanities.
So. So the question is, yes, as you pointed out, I'm basically just going to do what you said, except more slowly and stutteringly, which is that does this throw? You don't know, and so that's the problem with problems. You have no idea.
This is why I don't like writing JavaScript. Like literally, this is why I don't like it. You know what I mean?
You get very anxious. This is the anxiety that was building in me when I was a Ruby on Railsman, Ruby on Rail worker. And because in order to know, you can't look even at the type, right? It's a promise that says number.
Yep.
Because promise only tracks the happy path. Promises only track the happy path. That's the interface. Promise of T. Yay, tea time.
Yep.
But you have to look at the implementation to know, and then think really hard to know. And then if this called other errors and other functions and other functions, you would have to basically explore the entire call stack to know if it could possibly fail. And what's even worse, actually, is that, well, let me go back to here. What's even worse is you don't know, maybe acquire riches internally might have thrown, but it was caught in acquire riches. Like when I've worked in code bases that use promises or promise like data structures and Scala, there's a promise too that has similar problems. You end up recapturing and relogging the same errors, and you have no idea like if it's redundant. You just kind of you're operating in this sort of fearful, anxious mindset because you're afraid that anything could explode at any moment, or you don't deal with any of it, and then things do explode at any moment.
Right.
So it's either redundant handling or no handling.
Or you thought you dealt with it, and it still blew up.
That's true. Yes, something changed. If you change something, if you delete a handler, like nothing is going to. It's going to type check just the same.
Yep.
So you have no guards, and it makes refactoring very frightening. I think that's the worst part about JavaScript is that like you do not want to touch really anything that works.
Yep.
Because it's inevitable that you'll introduce bugs, and you'll find out about them by a data dog.
Yeah.
Use this coupon code. Kit linked in that.
Use coupon code broke boy.
Okay, so here I'm handling it for some reason. I don't know why I'm handling it. I forget. But yeah, basically, I guess this is an example of that same situation where the subprogram does catch in this case, but you don't know about it. It's still the same exact type. So when you're in the program, you might want to try to catch it again because do you really want to explore the whole code base? Does it throw? Yeah, so that was what I was getting at here. It was one of the earlier slides, so I've somewhat forgotten it. But now, effect. Beautiful. Okay, so boom, ugly, beautiful, beautiful, gorgeous. So the first is the success type. The second is the error type. So implicitly, it's never. If you don't specify it, it's never. And therefore, which is a nice, clever thing. I like this.
Yep.
Anyway, so it's never. Therefore, you know it can't fail. So if you look at the type, assuming that somebody wrote this following Effect best practices and wasn't trying to trick you,
Yes.
you would know that you could just call this and not have to stress. You'd be like, okay, what are the semantics of this function? What type does it return? This is an honest representation. The type is an honest representation of its semantics. And
Yes.
that is like the ideal of type systems. That's what we want to use them for. Not just have this happy path blindness. Trademark Dylan Mulroy.
Nice, nice.
Which somebody on YouTube said, well, it's not happy path blindness because you're not blind to the happy path. You're only looking at, but then
that's a
it's complicated. So Dylan, I don't know. Is it the happy path fixation? Sad path avoidance?
Wow.
But I'm going to stick with what's trademarked.
Okay, that's smart. That's smart. Yep.
Sharts fired. Sharts fried. Okay, so so this cannot. So yeah. So acquire riches cannot fail. That's why the program cannot fail at this point. However, if we look at the implementation, we can if we want to. If we want to get a sense of what kind of bounty we're in for, 350.
Yeah.
But if it's changed, if we say randomly fail half the time by using the nice random package and getting ourselves a boolean, and your teeth melt. So let me run this real quick.
Makes sense.
Your teeth have melted. Maybe we'll succeed. Maybe we won't.
Yep.
Yay! Hooray! So now at this point, if you compile, this becomes a compilation. If you type check, rather, I should say. I'm Scala brained a little bit. But if you run TSX or whatever, TSC is a missing ancient curse in the expected effect errors. So if you use the effect language service provider written by Mattia, which I recommend, it'll translate ugly error messages into something readable like this.
Nice.
And so you can just regenerate the type and it'll compile again.
Yep.
So it's nice. And basically the error is introduced and composes and propagates upward. And it works in this generator function, which is the coolest thing ever, even if it's behind this Boolean and the should fail bit. Like just by yielding an error type. And the ancient curse is like something that extends this thing called data.tagged errors, which makes it nicer to work with this stuff.
Yep.
But you can yield those, and it's the same as calling effect.fail with wrapping it. So it's a little simpler.
Yep.
Anyway, and the second you do that, it will force that into the error. So if acquire riches was the previous implementation and we added that and didn't update the type signature, that would be a compilation error, and we would have to regenerate the type to represent what happens. So you can't really go wrong. By introducing an error, it's going to force you to resolve the consequences of that through your application.
Yep, or intentionally ignore it, or something else. But you have to, you know it exists.
Yeah. I mean, you have to deal with it.
Yep.
You have to deal with it somehow in the code to get it to type check. So you could do effect or die to be like, whatever, I'm not going to deal with this. My program can die, which is kind of like the default behavior of promises. And then it's not being tracked in the error message. And so maybe you want to do that sometimes if it's rare enough and there's nothing you can do about it. So yeah, similarly, make deposit. Toss money upon the wealth pile, but it can also your banker's teeth could melt as well.
Yeah.
And now we can have a union of all. It's getting a little smushed, but that's okay.
I got it.
I got all this. Possible. Thank you so much.
Yep.
Yeah, we're getting good at this. So yeah. I know. So all possible errors are tracked in the type system, basically, which is really cool as this union type. Which is very, very fancy. And so that's just half of it. Tracking errors is great, but what good is tracking errors if you cannot deal with them in any way? And so Effect has many ways of dealing with them that are just as granular as the introduction and are just as type safe as their introduction. So it's introduction elimination rules from whatever you Lisp freaks out there, scheme freaks. Okay, so here's a program that uses our other subprogram, which I've renamed Biz here to save horizontal space.
Our business plan, I like that. Yep.
Yes. So there's catch-all is the first one. And catch-all takes a handler, and you get to decide if it errors, what do you want to do instead? So this is not too dissimilar from whatever the promisey thing is, except it's type safe. So
instead of just
it knows
unknown.
the error here.
Yeah.
Instead of unknown, the error is now the union of all possible errors. And you can match on these in various ways. And by calling catch-all, it eliminates the error from the program.
Yep.
So we can now safely type it as just effect number. And this is representing what's happening inside of our program.
It makes sense.
Which is very cool.
The type's not lying.
In a real HTTP, Effect does not lie.
Yeah.
It tells the truth. Even if that truth is an ugly truth.
Yes. Sometimes your code is ugly, guys. And Effect's just telling you how it sees it, you know? Sometimes you ask your wife, like, is this shirt... what do you think about this shirt? And she says, it's weird and bad. And you say, thank you. That was a close call. I almost went outside with it. You know what I'm saying? That's what you need to know.
Effect will tell you your shirt is sort of a weird white checkerboard frou-frou thing. And it'll make you feel bad.
But
You
then
look
you'll
rather
know.
ostentatious. Then you'll know. Yeah, Effect will tell you your code is ugly.
Yep.
So Effect program catch all. So here's the version that catches all. We see that the error was caught and it defaulted to 0 riches. So the program succeeded, even though acquire riches. Your teeth still melted,
We got
but the
0
program
riches.
resolves 0, which is pretty great.
Yeah.
And then if make deposit fails,
yeah,
once again, it'll
Makes
be caught
sense.
here. So, or nothing will fail and we'll have a good day.
Wonderful.
So the catch-all will not be triggered. Now, so that's all type safe. And if you want something simpler, there's or else succeed, which is just like if you don't want to log and you just want to, okay, fail or go to this, great.
Yep.
Now, there's more though. There's even more for all this. You can catch just one.
Okay.
You don't have to deal with every error.
Yep.
If you have like 2 different subtypes of errors, you have like really bad errors you need to recover from and medium errors that you're cool with or warnings.
Yep.
You can just handle one set. And if you have type aliases to these unions, because these unions can get kind of complicated, so you might want to like type alias and app error and like union all your errors, or even have subtypes for that, like type error, account error, and have a union type there.
Yeah.
TypeScript will actually preserve the unions
really?
in a very cool way. Yeah, I was surprised to learn this, but it doesn't just flatten out all the unions. If you have aliases, it'll preserve the aliases. It's very cool.
Nice.
And so you can catch a tag here.
Yep.
And now, by just following catch tag here, we're only catching the ancient curse error, which will remove it from the union.
Yep. And error is exactly the ancient curse type.
You got it. You're ahead of me.
Got it.
Thank
nice.
you. You know
Very
my slides.
Cool.
You know my
Love
slides.
This. Yeah.
And then there's even this other one called catch tags, where you can supply sort of an object.
Ooh.
if you want to do multiple.
Nice. I like that one the most because it makes me feel like I'm doing pattern matching.
That's one of the problems with TypeScript, of course, is that the pattern matching support is kind of janky.
Yeah.
Effect has many things to many people. It has all the concurrency stuff. It has all this structured concurrency business, which is very useful.
Right.
It has the tracked errors, and it also has this kind of a standard library aspect of having these ways of creating data types. So these errors that we made before, these error types, and if you use those, you kind of can opt into sort of a hacky pattern matching syntax.
Yeah, have you guys thought about making your own TypeScript compiler? No, I already. I know that you guys already did that. I'm sorry. Might be painful right now.
No, that was Michael's journey. I think when I met him, that's what he was just getting started with. But yeah, Michael
I already know about that one. Sorry, guys. Sorry, I know I'm banned from the community now. Yeah.
But if I could use it as sort of a prompt, like I think it is worth it, because another sort of thing I see from the peanut gallery, which is a vast peanut gallery, which I understand, I mean, I get it. Like I get anybody who's like, I don't want to write a program like this. Mm-hmm. They're just peanut people, and they're lesser, but they're very valid emotions. Yeah. So it's worth considering. No, but I completely understand. Like we're saying, or like we're coming down from the mountain saying this is the best way to write things. Yeah. And it has some awkward edges, so we deserve to get some tomatoes thrown at us. But they'll come back and they'll say, well, why you should be using another language or write your own language. Yeah. And it's like, I did use another language. I used Scala for years.
I tried so many late nights. I tried, guys.
and it just, network effects are, got hands, and they're too powerful.
Microsoft's spending like several $1 million a year on doing TypeScript things. Like that actually, believe it or not, guys, that kind of makes a difference.
And you want to, it's going to get better, ideally too. Hopefully, as Effect grows, and we're already sort of talking with the TypeScript people here and there. We have a few, ambassadors or whatever. Maybe they'll be more
undercover
amenable
agents.
to our.
I love this. Yeah.
Yes. We have some double agents. No. I'm not sure. They're not going to like rewrite TypeScript to be Effect, but maybe they will help us if we need, if we can think of some really clever ideas that don't break TypeScript, obviously, and are good for everybody. Mm-hmm. So yeah, I think it's only going to get better from here. And as I mentioned, it used to suck 2 years ago. I wasn't using Effect 2 years ago, and I saw that syntax that the primary agent observed, and at that time I was like, ooh, this isn't Scala. This is pretty gross. I can't deal with all that syntax. Yep. Once I saw their post where they came up with this version of the generator syntax, it didn't have the weird $ business going on. I was like, okay, they're on. This is happening. Like now, it's
Yeah.
possible for me to come along, and I feel like for other people as
Mm-hmm.
well. So anyway, I've tried other languages, and making your own
Yeah.
language is very hard. Like there's really good reasons to go where the people are and to make it work. And especially like it's not. I'm really sensitive to syntax. I'm a
Yep.
pretty big snob. It's tolerable.
It is.
You get used to it. And when LLMs are writing it, and you have enough patterns in your code base
Yeah.
that it can base a new code upon,
Yep.
it's a very normal way of writing code. Like it's very unexceptional. You sort of we didn't get into like the service stuff or the layer stuff, but it kind of also offers a way of organizing your applications in a very structured way, where
Yep.
that kind of removes the question of how do I structure my applications. You do it this way every time.
Yep.
And you just get to focus on the problems that matter.
Yes.
Anyway, that was a mini ramble there. But yeah, that's kind of the error handling stuff
Yep.
I wanted to show off. Yeah, I'll take another break there because I've just been rambling. So any thoughts? Does the chat have any good ideas?
I don't know. Chat, you guys want to ask any questions? I mean, so far this is all still making sense. I like the one that looks closest to pattern matching. That one makes me happy. They want to know, can they have pipes yet? I think they tried, guys. They're still trying.
There's no pipe operator yet. There is
Yes.
a pipe method where you can do the same
Yeah.
thing and just sort of have var args
Yep.
inside a pipe. But yeah, no pipe operator. I don't think. Maybe I saw some. Anyway, I don't know.
No, they're getting
I
closer.
don't know about that
TC39 will get
I know
there by
people-
2039. I think that's what the 39 stands for.
I know, yeah, people love the pipe operator.
Yep.
I'm sort of indifferent, but if people like it, I guess it's probably coming.
Yep.
All right, so I have some more things then that are also worth showing off. Some cool other
let's
features.
See it.
So with regards to error handling, so here's an example of the short circuiting business.
Right.
Just wanted to show that off. And here I do have that error union.
Yep.
Of app error being account credit or payment error, and that type propagates just by using these three with those errors. It'll figure it out and union them. This all infers. All the types always infer.
Yep.
Cool. Boom. Okay, cool. Now there are some other error handling things. There's or else.
Yep.
So here's shoot first, ask questions later. So shoot might fail.
Yep.
And if shoot fails with an out of ammo error, then it will run the question. And if you look at the type here, result, the only error message is brain fart. Teej, can you guess why result can only fail with brain fart, but not out of ammo?
Or else must handle that separately, right? So then if we have an error either way, well, wait. Let me look at this. Shot or answer. Yeah, so when the first shoot fails and we get the out of ammo, well, we're not handling it or doing anything. Or, well, we are handling it. We're just not just throwing it away. So it just doesn't matter. We could probably do something. I'm assuming this or else takes the error as a parameter.
Or else is kind of like a catch-all, except it doesn't give you the error in a way.
Okay,
right?
nice.
Like,
so that's just like saying, like, I don't even care at all what you did before. This is like result dot if error or whatever. It's just like, I don't really care. We'll do something else. Yes, this makes sense. So we're just gonna say, run this, return shoot, which could be shot, right? Because we did that. And then any way that fails, we'll run question. But since this is effect, we're going to run this completely like when we're here. So we're either going to get a new success and that's going to get smushed into the success value, or we get a new error and that gets pushed into the error value. That's why we have shot or answer. Is that like a fair way of saying it?
I think so. Let me attempt to reiterate and see if we're on the same page. So yes, the semantics are first it will run shoot. Or else, if that fails for any reason, so you might get shot, it might succeed, and then you're going to get shot. So the success, the success type shows this. Or if it fails, we're going to run the second effect instead, which might succeed with answer or brain fart. So you're never going to get the error from the shoot effect, because if it did fail, it's going to run the question. You still might. You're not recovering in any way from the question error, so that might occur. So either shoot succeeds, or question succeeds, or question fails. And that explains sort of the union of these two success types, and the single error type here.
So the success type keeps on getting like, it's like it's getting unioned, but it feels like, we're squishing the success type of every effect back into the parent, or I don't know, like the final success type.
That might make sense. It's not exactly what's happening at the runtime,
Right.
but
Yes.
it makes sense. Like at the type level, one could
Yes.
think of, yes, you're going to union all the possible successes together or the possible errors
Right.
together.
Yep.
And this all infers, so you don't have to worry about it. You don't have to type
Yes.
annotate it. You
Right.
can use the effect LSP, and it adds a plugin for adding a type annotation if you
Yeah.
want to be lazy. So yeah, they could still both fail, and if
Right.
they both fail, the final error is the brain fart because
Yep.
out of ammo. Well, yeah, and you can actually
Yep.
hover over the little shapes, and it'll show you the error that it failed with.
Oh,
You hover over
nice.
result. There you go.
That's nice. I like that.
So yeah, it went there. So yeah,
Nice. Totally
Yay!
makes sense. This is
Okay.
great. Yep.
Cool.
Ah,
So
nice.
here's another
Or
one,
else fail. Easy peasy. Now instead of returning to the success, we're going to return to the error value because errors are values.
Exactly. And we have this too slow thing, which was created with the effect, whatever tagged error business. So you get this make constructor. And so, yeah, there's a timeout thing, which takes an effect, which doesn't fail, but returns a pizza. But you only want your pizza if you get it within a second. So if I run this.
Dang. That's fast pizza.
If it's too long, notice what happened to it. It interrupts the error. So
Right.
it interrupts the pizza because the pizza didn't fail. It can't fail. But
where's my abort signal, Kit? See,
exactly. You don't need it. Or maybe it's inside of pizza, or it's inside of pizza with the signal. Anyway, I'm literally interpreting your jokes as as technical questions, which is how.
Well, that
how
one was more of just like that was
vision.
just a softball pitch for Effect to say, you know, we're handling that for you. You
I will
don't
not-
have to write the 1,000 extra lines to handle this.
I will not turn that down. Thank you.
Yes.
So yeah, that's basically there. And of course, if it occurs in less than a second, 465 milliseconds for me. I don't know what it says for you.
Yeah.
Oh, 541.
Nice.
Then yay.
Yep.
It works. One other cool one. Eventually, I want you to guess now. And now it's going to be a quiz. What does eventually do? Look at the types.
Eventually. It's going to keep on retrying this until we get it to work. Nice. Called it.
Pretty good.
Nice.
So of course that removes the error type because it'll keep going and maybe it'll keep going forever and ever.
Right. It could infinite loop.
Yeah.
If you have something that just always fails, it'll just keep going. It'll keep trying and trying and trying and trying.
It will forever and ever.
Right.
It does do what it says on the tin eventually.
Yes. Right. Yes. Yep.
Cool. And now, so this one is a little weird. This is an error handling one. I like this quiz mode. So
yeah, let's do quizzes.
I
like this. Yes, I like the quizzes. Okay. So we have function. It's like takes something that is lickable and it either returns a string that we like something about that, I guess, and then otherwise it says we had an error. Can lick ice cream, I'm assuming. Toads, probably yucky. Lollipops, maybe that will work. Partition items and perform lick. Items are the things that we have, and perform lick is our function. So we're gonna call perform lick on each of the items, and then we're gonna get how many either a list of failures and a list of successes. I'm assuming that's what we get back.
Yeah, so notice the error type goes away with the final result.
All right, because now we're going to get
with
back
the
ones that failed with their actual errors for each, and we're going to get back their successes for each.
What do you think the type of fails and successes are, respectively?
It should be a list of lick errors and a list of strings.
You got it. And I don't know why string. This is obviously made up nonsense. I never had to implement this, so it's nonsense. But and I realize it's funny.
It's the response to being licked.
Yeah. Yeah. What do you know about computer science? Don't you know what happens when you lick something?
Yep.
Okay.
Nice.
So what did you get? They were all demonic, actually.
Oh,
in this case. I'll try it again. It's different for both of us.
Okay. Nice. The lollipop was good. Very cool. Nice. Yep. This makes sense because we're mapping all of the results to this string, which just tells us like how many things failed and how many things succeeded. This makes sense.
Exactly. Wow, you're getting a lot of demonic snacks.
That's tough. That's tough.
Wow. What's happening to you? Come on.
Oh,
there we go.
Oh, we almost had the perfect run. The anointed run. This is a crazy roguelike you made.
That's what the stream is now. Now we're just going to be streaming the lickable game for the next hour until we get a perfect.
Oh man!
And there's a bit of time variance too, so we could try to like get the shortest.
Oh yes, shortest perfect run.
Speed.
Yep.
Speed run this. Anyway, okay.
Yeah, this makes sense.
So yeah, that's partition. Yep. Because we have all this interesting information at the type level, and we have this interesting interruption semantics and other powers, this global view of what might happen. Effect can expose all these really interesting combinators, which is a fancy word for function if you want to feel important.
Yes.
So it exposes all these fancy combinators like partition and other ones that can play with it in different ways. So all short circuits and might run them in parallel or might not.
Right.
Partition runs all of the list of items with the effectful function, and it will not fail.
Yep.
And it'll give you two different sublists of all the successes. There's one called validate, which will succeed if they all succeed. Otherwise, if it fails, it'll group up all the failures and it'll fail with one sort of array of failures, essentially. So that's like if you want to, validate some form input or something, because you want to collect all of the failures instead of just.
Yeah, totally. This makes sense. 100%.
Exactly. Instead of short circuiting. So a bunch of different powers you have. And then maybe one of the last ones, this one's pretty fun, schedule. So guess what's going to happen here?
We're going to repeat checking our notifications on the phone. It's just like, I'll check it, and I'll wait 2 seconds, and then we check it, and we wait 2 seconds, and we check it. Like that.
We've all been there.
We've all been there. Relatable.
Twitter X.
Ooh, I like this. I like this little, graph thing. I don't know what you want to call it. That's really fun.
Yeah, it's a fun graph. I'm going to call it a line chart or a schedule visualizer component. Anyway, it's going to keep doing this.
Yeah.
Until I believe eventually, it's actually telling a sad tale.
Yeah, it is. Battery low. Ooh,
but
nice.
eventually it turns out that I didn't have types for this one, but one might imagine that phone actually can fail eventually.
Right. The phone is dead, so we couldn't do it. So phone dead error. And then it would.
Oh, no.
For me, never. My phone's got a lot of battery.
I'm not sure if this does fail. Actually, maybe I changed it. It's been running for 46 seconds.
Oh, nice. There we go. The suspense. Cool. The suspense, man. Yeah.
The other cool thing about this visualizer is if I do stop it, it will interrupt the effect, which is kind of cool. But anyway,
nice.
So it uses the effect semantics. Okay. Yeah. So repeat is cool. You can take an effect and you can give it a different kind of schedule. Yeah. By the way, I didn't address this before. 2 seconds is type safe using the template string insanity magic of TypeScript, which is not something you can do in other languages. Like TypeScript's effect system or type system is pretty insane.
It has its own language, so you can just write strings and have magic happen. Yes.
Pretty much. They use it. You can there's other constructors like duration.seconds2, whatever you can call that. But if you want to get fancy and keep it simple, this is type safe.
I'm assuming there's different kinds of schedules, like I want to exponential back off or do things like that.
You got it. In fact, I believe that's right here in a moment, exponential.
Nice.
So let's try this one. So we're going to keep attempting a parallel parks. This one is one that can fail. I didn't have the types I should have. Whatever.
Yeah, we get it. We get it.
Or failure park. This is an allegory. Okay. It failed.
Yep.
Too close. Too far. Neutral.
Oh, come on. You got it.
And of course, it's getting exponential. Focus.
You got to get it this time. You're taking 6 seconds to park, brother. You got to get it. You got to get it this time.
Hooray!
Nice. Yes. Very cool. Yes.
Took a while.
That's because we're constructing up we're basically declaring what we want our program to be, and then because we're doing that, we can do cool stuff like automatically having exponential backoffs.
Yes, because it's a subtle thing. I mean, people. I mean, I said it before. It's a workflow. It's a blueprint.
Yeah.
Because a park, it doesn't need to be a function call either. I don't know why I made it a function call. The attempt parallel park that could just be a value because effects are blueprints.
Yep.
It contains a function inside it. Essentially, it's no magic. Like the magic of blueprints is functions. I made a video on this called like the magic of thunk or something on my YouTube. Whatever. If you want more of a lecture there, but
check it out.
Yes, check it out. Like and subscribe.
There we go.
So thank you. Park. Because it's a blueprint, we can run it again. It's because you just call the function again, essentially internally in the effect runtime, because effect wraps it up in like when you called effect.sync, right? You had to give it a function constructor. You're sort of doing the magic for it. Like it's just keeping that whole thunk, and it's running it again when you want to run it again. The nice thing about wrapping it up in an effect instead of just having a functions of promises everywhere is that it's hard to keep everything in a function of promise, and there aren't many tools for combining them. Effect basically gives you a toolkit for composing these funky things, these lazy evaluations. But yes, if this were a promise, if Park were just a promise of something, how could you retry it? A promise is a representation. It's a handle on an ongoing computation that already kicked off, or maybe already completed, or maybe already failed at some point in the past. So you can't say, it's like trying to defibrillate a very dead horse.
Yep.
I guess. Anyway, so yeah, it's kind of the power of everything. There are a couple more here. So there's like, these schedules are very powerful and you can do crazy things. So this is like while, so both every 400 milliseconds and while the duration is less than 10 seconds. So I'm using the other form of constructing a duration. So this will repeat.
We're going to keep eating hot
400
dogs.
milliseconds. It's a hot dog eating contest.
Yep.
And also the hot dog takes a variable length. So it's a bit of a, you don't know how many hot dogs we're going to be able to eat.
Oh, yeah, true.
And we got, how many hot dogs do you get?
I got 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10, it looks like.
Wow. I only got 9 hot dogs.
Yeah, pretty good.
Off the screen because it's so many hot dogs. Amazing.
Yeah.
Okay. Yeah. And if people want to play with these themselves, go to effect.kitlangton.com, play with them after the stream.
Yeah.
And yeah, they're sort of, they look different on that website.
Yeah.
And then the last schedule one here is retry again. So there's repeat, which lets you just like repeat after it succeeds.
Right.
Just do it again and again. Like some kind of cron job. And there actually is a whole cron module for schedule that I have to mention. I'm legally obligated to mention, made by our friend Sebastian.
Yes.
Yep. Anyway, and then but here's another retry where it's the same thing. Recurs is 4. So this is going to be every 2 seconds up to 4 times.
Got it. And then it could still fail.
Snooze button.
Right.
And then there's 2 things. Yeah, exactly. So.
Right.
Oh, sleep forever. But it might succeed too. Like it might.
Right.
It's only doing the retry if it fails. If it succeeds, it succeeds.
Then it's done
and it ends.
Right. That makes sense. Because right.
So
me
two
too.
snoozes.
Yep.
Yeah. So yeah, that's schedule. Anyways, that's just a whole other thing. Let me see what else I've got. I've got so much shit. How are you feeling?
This is all great.
Yeah,
I love this so far.
I had AI generate the schema one for the the most part. Like,
okay.
As I started this, you texted. When did you message me?
I messaged you like I don't know on Monday or something or. I don't know.
Monday.
Yeah.
Yeah, and then you're like, "Do you want to come on the stream?" And I'm like, "Oh, maybe.
Let me see." They said they want resource safety. Well, first we need to talk about schemas because it's this slide.
Yeah. I mean, we could talk about resource safety. I don't even know if this is a good one. But here. So like, yeah, I'll just look at this one.
Yeah.
So this one is using. So here's once again, like not the one could imagine install in OCaml a more concise way of creating structs or ADTs in general, right? Like that's not Scala.
You can, but it's painful to get JSON working for some reason because academia. I don't know. It's just like.
So what? Effect, too many words in my head. Effect exposes this thing called schema, which is kind of like ZOD, except it's almost just like you can use it kind of as just like a way of describing classes in general.
Yep.
Or data types in general. And you get free encoding and decoding. You get other free capabilities. There's like a tagged class that gives you a tag so you can do pattern matching on. We can look at that. But what's nice about this is if you describe an API as a schema, now it knows how to decode this from JSON. So just like ZOD or whatever. Except it also works with all the effect libraries, etc. I think ZOD recently added the ability to both encode and decode. For a while, I think it was only decoding.
Nice.
But anyway, this is bidirectional. And always has been. So ZOD's amazing though. So okay, HTTP client.get. We're getting, so this, instead of using fetch, you might use this. This is going to get you some response object, an HTTP client response, believe it or not. And then there's in the HTTP response sort of module object, you can call schema body JSON, give it the schema you want to try to decode and the response, and it will return that. And of course, this might actually also return a failure. I might have mistyped this.
Quick question.
But whatever.
I see the word class. Is Effect no longer a fan of functional programming? Oh, exposed! Exposed live! Michael loves object-oriented programming, dude. That's crazy.
I mean, there are some benefits. Man. I'm going to keep Amelia Bedelia interpreting your jokes as technical questions, which is not fun. But
no, you have to have it as a class because we're going to give it properties and functions. Interfaces don't have this. You can't just make an interface. You can't do other things.
You can, it would be possible to make something like const API user. There's also a const version of the constructor, but then for TypeScripty reasons, it would just be like its type would be the structure of its interface. Instead of, by having a class, it's the only way to get sort of a unique nominal type API user that you couldn't use in place of somebody else called like API person that had the same exact fields. Like, it's
the
very the structural
structure.
typing.
That's structural subtyping. We don't want that for this.
It would be structural, bro. Is the best way to say it. Dude, that shit's structural. So you don't want to. Anyway, nuance. Just follow the patterns. Like
Yeah.
this is something that in the next version of Effect we're going to work on the docs more and hopefully coalesce some best practices on.
Yeah.
But there's
No, it
look at
makes
the docs
sense.
now. Anyway,
It makes sense. This is good. You can also
Okay.
do people ever write anything inside of a class definition for this, or you don't? Is that like a thing? Would you do that? I've only ever seen people when they
you
write.
you can and because it's a class now you can have methods written static or whatever methods written on
Cool.
there. Yeah,
Nice.
so that's another benefit of the class pattern. And for some reason, I think maybe I'm actually whatever. I had the AI do this. I think it's actually trying to hit JSONplaceholder.com, so it's failing. It worked on localhost.
That's funny.
And it's failing
Yeah,
here.
that's
So it's
funny.
pretty hilarious.
Mhm.
And I think there should be an error showing in the type here. But
Yeah.
anyway, sorry, blame me.
No, this
so,
this
yeah.
makes sense. This is awesome. I see something else. We have effect.provide.
Yes, I was going to hide from this. I was switching the slide away. But yes, so there's this whole other component. And I didn't really make too many slides for this, but I'll try to describe the implications and the thought process.
Okay.
So in addition to everything else, Effect gives you these tools for dependency injection, which is something you really do want in large applications because it makes your code testable. For instance, I mean, you're used to it, even if the word dependency injection is strange. Like, I like to think of programs as two things. You have, syntax, the code that you read, the sort of the high level program that you read, and then you have the semantics. And things like interfaces or traits, or is there something similar in OCaml?
It has the classes, like it has objects that are structural, like subtyping. Is that what you're saying? Like,
Okay,
you can do.
Yeah, I meant more something like a Rust trait that might have multiple
no, it doesn't have it
implementations.
actually.
Okay.
Nope.
Yeah, I mean Haskell doesn't either. So I mean there are other crazy ways of dealing with that
Oh,
problem.
you're saying
but
for
it's really nice
functors?
to have.
Maybe, I guess. Yeah, module functors kind of, but it's confusing if you're not an OCaml person. You say functor, they're gonna think of something else because it's the wrong one. It doesn't matter.
Okay, I will
It's
avoid
okay.
that.
It's okay. I know what you're saying. Yeah.
Okay,
Yes.
perfect. So you have in many programming languages interfaces, and in
Mhm.
many programming languages you can have dependency injection by. Why are interfaces useful? Is because you might have multiple implementations that of the same class, but they have the same interface. So a user service, you want to be able to get a user, or a in this case an HTTP client. You want to be able to have a method called get, given a string URL, get back some HTTP response. But you might want different implementations. For instance, an actual HTTP client. Well, in our case, we want, because this is running in the browser, theoretically, we can use an implementation of that client that delegates to the underlying fetch built into whatever, or even Node, right? They have that. But there are other implementations of HTTP clients that you might want to swap in there. And it's nice to sort of make disjoint the interface from whatever implementation you eventually swap in. In a normal sort of non-effectful code base, you might have the implementation. You'd still have an HTTP client trait that had a certain structure of like get. But then maybe the const fetch user would accept an HTTP client, and you would just call into that. So you can thread through your program via parameters, different implementations that you would determine at the top of your program later on. Now that gets very verbose because you have to thread these parameters everywhere, but some people are a fan of it because it really can't get any simpler than that. And what that allows you to do is not only swap in implementations, but most importantly, when do you want to swap in implementations the most?
When you test, or when you're running in weird places.
At test time. Like in particular here, I don't think we have this yet. If we don't, I would really like to make one, which is a recording HTTP client. So like if you used a VCR library in another one. So instead of just hitting the web, you can have an alternate implementation that might wrap a real HTTP client. But first, before making the actual request, it checks some JSON encoded cassette of previous requests and plays them back. So you can basically hot swap implementations through your program without having to pass them in through parameters.
I used a cassette player yesterday in real life, believe it or not. So that's pretty cool.
A cassette player, not a cassette layer.
No, a player. Like I put in an old cassette into one and played some old books for my daughter at my grandma's house. Boom.
Oh, wow. Old book. What kind of old books?
Oh, just like little ones, like Jim Likes Blueberries or something. I don't remember which one. There were a bunch of random ones.
Yeah, I'm sure like an audiobook cassette. That must have a nice vibe to it.
Oh, it was great. Spooky. It felt so good when it was done. I had to press rewind because I did not want my mom to find me leaving cassettes at the end. I knew I was going to hear about it later. You know what I'm saying? So it's like, I have to rewind.
Teej, I went to go listen to my blueberry cassette, and he was in the middle of eating the blueberries, and I was
Ah,
very
no!
distraught. How did the blueberries get in the bowl?
Who is playing? The cassette's halfway through.
um, so, so yes, rewinding my mind, if you will, my cassette mind.
Yes.
The layers are this way, albeit slightly. This is probably one of the largest semantic hurdles for people, because it's not really a common thing. It doesn't have a direct analogy unless you've used something like Zio.
Yeah.
It's a very clever solution, and I don't have many good examples here, but one could imagine, if I did not provide that particular implementation, which is, and the way you provide implementations are these things called layers, whatever.
Yep.
Won't get into that, but pretend that's an effect essentially that constructs an HTTP client, potentially an effect that constructs an HTTP client.
Yep.
And it's then going to be used. It's going to provide you an HTTP client, which is going to be used wherever we yielded to that HTTP.get call there. Now, if I did not provide it, there's a third type parameter, which I've not shown off, which is a list of dependencies, another union type of everything every interface that you went to reach out for that you did not provide a layer for. So generally, these would, just like errors accumulate, these would accumulate, and at the top of your program, you would provide a layer that satisfied all of these things. And there's some other ways of organizing your application in this service-oriented way. We just did an effect office hours yesterday that went into this. That'll be on YouTube soon.
Nice.
So that's kind of a whole other conversation. I don't want to get there just because I don't have slides that make it really clean. But it can be understood, and you don't have to worry about it at the beginning. But it's like, I can only tell you, if you've trusted me at all, if I've sold you on anything in this so far, the error tracking, the recovery, the concurrency stuff, the way effect works, this might be weird. It is my favorite thing in the world. Like it's so frustrating to structure. I don't even really know how I would structure applications any other way anymore. It is so addicting almost, and like calming. That anxiety I felt in Ruby on Rails, like it gives me a framework for designing applications that I would deeply miss.
This makes sense to me. This is like, for me, it seems like these are basically like arguments to my program, right? And we think it's dumb to use global variables for everything. Like, you would think it's dumb if you had every parameter listed at the top of your program for all of your possible functions, and then you set the parameters for those things and then called another function. You'd be like, that's insane. You have foo xyz bar a at the top of the file, and before I call the function, I set it to the thing that I want, and then I call a function. You'd be like, that's crazy. So like, but in my mind, when I've read about this just seems like, well, I want to parameterize my program. So that makes sense to me. This is good. Yeah.
It's sort of an implicit way of propagating these dependencies. It's basically identical to if every function took an extra argument, which was a big map of all the dependencies it used, except we're also type safe, just like everything else. And these layers can be swapped, and like different layers, different implementations. So we want an HTTP client. This one may not have dependencies, but you can imagine another service or something like a user service that depended on a database. Right. And by providing a user service layer, that might transitively depend on a database. And then you could pick an implementation of a database. So it's like this Lego building block. You build a little tree of your internal dependencies out of these layers, and it's type safe, and it gets constructed. And another problem with that sort of global, there are a few variants to solving this. I mean, you could use another dependency injection framework, like there are some for TypeScript, I think. They're not type safe, and they're kind of weird, and just as weird in a way. And they're not compile time type safe. Or you could do that approach of, like, there's the basic approach of just that construct everything, pass it through parameters. That's really verbose. It works. It's just a little verbose. And most people don't like it for that reason. It gets really hairy if you have a big program.
I feel like the one I see more often is just like, I have a database module, like we load it up at the start, and then I just like reference that thing the whole time, right? And it's like that, but that's just saying I have a global. Normally we're like, global's bad. But then you're like, oh, for big things, which, I mean, it's like, it's fine. We use globals all the time in my game I'm making with Prime, because it's a game. So sometimes there's fine where you're supposed to use globals, but like, yes, it makes it very hard to switch them out. Yes.
And I think that's why so many people talk past each other on the web too. Like you have all of these threads of like people arguing past each other. It seems like people I respect immensely, like, the Jonathan Blows and the Casey Muratoris. And they work in games, and it's a very particular, like, really hard engineering discipline. And there's certain patterns that these games exist in. Like, do they have the same maintenance guarantee? Different
Right.
shaped programs have different qualities, and like
I
you,
got
it
it.
sort of
My wife's
shapes
calling me.
user.
1 sec.
Oh,
You can
please,
keep
please.
telling Chad about this. I agree with you. 1 sec.
Let me tell you. Oh, I'll actually just show off my cat again. 2 seconds. Will probably just hurt me. Hello. This is Worm, and she sits on my computer, and she has no hair. Oh, I can look at the chat. Let me do this. I don't know how TJ does this. I want to get a CAT scan of his brain. Did you shave the poor cat? Yes, I shaved it. That's why I'm covered in scars. Um, oh, CAT scan. See, I told you not to mention any accidental puns. I miss effect most when writing Rust because of the dependency injection. Oh, yes, I agree with it. Who's this? Who's this? Min Bad Blue. That guy's onto something. Are the animation CSS? Oh, yeah, I could talk about that. I mean, I guess Teej probably wants to know too, but I'll tell everybody. Which is no, it's all TypeScript, and it uses the motion library for the animations. But to get all the different fancy textual animations, there's like 4,000 lines of pre-processing code that sort of neatly animates and figures out the minimal line diffs using all sorts of different diff algorithms, and then constructs it into some like AST that it then processes to make it nicely animated at the with motion. Because you can't just do that with motion. You need a like syntax highlighter, and I have all these different like little marks for highlighting different things. Where's the place where I've done this? Can't find anything. Oh yes, they're all in laziness. So yeah, that like that, and having these animate between different positions. It's pretty crazy. I will open source it eventually. Um, but yeah, I kind of just barreled straight ahead. It's really ugly code, and it technically works.
That's the best kind of code.
Hey,
I'm back.
it is.
All right, nice.
Cool.
Okay, what's the next
I
thing?
tried
Let's
my
see the
best.
next thing. I got dependency injection. Very cool. What's the next one we're gonna see?
Yeah, I guess I do. I had
So
this
is it
make
like
some stuff
normally you
for me.
yield dependencies inside of? How does that part work? That's the
Yeah,
part. One of the things that I didn't get before when I tried to check
yeah.
this out.
So
Yeah.
so I had AI throw. I was like, hey, I make a dependency injection one.
Yeah.
And what it was this stay high. Okay, yeah. Like so, this is not really correct necessarily, but I'll
That's
talk
fine.
about it. So
Okay. Yep.
this is
Okay.
one way of doing it. So instead of defining an implementation, and it
Yep.
kind of does define an implementation here, I wouldn't have defined this greeting service necessarily. You could also just inline that right where it says greeting service, just inline the type.
Okay. So
So instead
inside
of
of
making an
the,
interface,
if you can see my screen right here, you
yes,
could
I'm
just
looking.
put this right here.
Yeah,
Got
yeah.
it. Great.
And then instead of making an interface, you once again you need a little more boilerplate, but you
Yep.
gain something from it. So yes,
Yep.
there's a little bit of repetition, greeting.
Yep.
Oh God, because it's a class, it gives you that
Tab,
nominal
tab, tab.
type. You need the string to identify it later on, but whatever.
Yep.
What this does is it defines this identifier, this special
Yep.
greeting thing called a tag.
Yep.
That basically you can think of it as that interface. It has this
Yep.
greet function. You can give it a string, it'll give you an effect back.
Wonderful.
Now there's no implementation here, so it's kind of akin to an interface.
Yep.
With a way of sort of summoning it out of thin air. Let me now go to, I don't know what this is doing. So, okay, this is a program that might use the greeting
Makes sense.
service. So you can yield one of these tags and it gives you an implementation of whatever that trait is. So
Yep.
read only greet. So that's what you get back when you yield it.
Yep.
So yielding it, greeting, it sort of acts as an effect that returns that interface. And then you can
Right.
call greeting.greet, which returns an effect, so you have to yield it. And if AI were better and smarter, or I had time to actually handcraft these slides, say hi would show its type, which would now show that it returns whatever the result
string,
of greet
never,
is,
greeting
which
service.
might be string. Does it return a string? Yes. String, never, not even
or
greeting service.
Right, just greeting. Sorry, yes.
Greeting, whatever that class type is there.
Yep. Yeah,
How dare
makes
you?
sense.
Which means that to run this program, and which is here in kind of in an ugly way.
Yeah.
So there's some other thing that it did. So you have to provide. So we have the say hi program, and now we have to. I would have written this differently. This is ugly, so give AI a break here. But
that's all right.
You take the say hi program, and you're calling effect.provide, and you're providing a layer, which is a layer that provides the greeting service.
Yep.
And it looks like they made a greeting live constructor that itself depends on other services. So it has to first provide that service. And if we can look at the implementation, it did this. Is this working? Or did it freeze? Is it still on? Can you refresh your screen? Because it looks like it might be frozen or
I don't know. It says, for me, it says program requires greeting. Oh, did I here? Oh, it's refreshing right now. I don't know where it's stuck.
Okay, maybe my app broke. Let's see. Maybe somebody finally figured out how to take it down.
Uh-oh.
No, it refreshes for me. That's odd. Funny.
It's thinking hard, spinning.
Well, yeah, I mean,
I shouldn't have. There we're back. We're so back. We're so back. Yep.
Huh? But is it showing the succeed effect?
I'm on succeed right now.
That is not the right slide. Something is disconnected WebSockety wise. I'm glad this didn't happen earlier because that would have been sad. Yeah, something is up. I don't know what.
Here, I'll try refreshing again. Oh wait, no, I'm still on succeed.
Yeah, well, here you can control it. Can you hit the hit Shift A to enter admin mode?
Oh, dang!
And now go to slide. Now go to deck 13. So smash that right button.
Oh no, I'm getting WebSocket is closed before the connection's established right now.
Some WebSocket error. Okay. Something happened.
That's
Whatever.
Okay.
This is what I get for building a slidey thing. But here, let me give you another website that you can look at. And then
I just connected. I'm connected now. I don't know what happened.
We're back. Okay, great.
I'm back.
Okay.
Yep.
I'm glad. Oops, I'm showing my chest off to the world. Okay, cool. So I'm missing a button on this shirt. All right, so what's happening? Yes. I'm glad this is into hour 3 is the one where it all breaks down.
No, that's okay.
I'm glad the first 2 hours are solid. Yeah, yep. cut off this layer trail. But so to recap, let's start at the use site. So the use site, you yield a greeting, which is basically like, give me this service out of the thin air. By the mere act of attempting to pull the service out of the thin air, it's adding an environmental dependency as that third parameter. So you're going to see greeting as the third parameter.
Mm-hmm. I got a quick question, just like pragmatically about it. Do you so you're writing effect, you're doing stuff. Does it feel like every time you use the database, do you put like yield database at the top of those functions? How would you normally, if you got like 25 functions, right? They're all here. Are you always doing like yield star my database, or are you doing like passing the database into parameters to those other ones?
So yeah, so generally. Yeah. So this is where I feel bad about presenting this because it's not exactly the idiomatic way.
Yeah.
But a little clue would be in here.
Yep.
So the way that stuff works, most of your application is going to be determined by these services that are defined in this way or in another way that's actually slightly nicer, but whatever.
Yeah, that's fine.
Something like this.
Yep.
Where you have an interface essentially.
Yep.
And then you have a live implementation, which is you have these layers that you define, and these define your constructors, basically your effectable constructors for your services.
Right. Okay. Yep.
And it's in here that you can, if you want to. So how this works is that you're saying layer.effect. So you're constructing a layer.
Yep.
Given an effect.
Yep.
The first thing you have to do is give it that tag, because that tag acts as a lookup key.
Yep.
And it acts as the type, whatever.
Yep.
The second argument is the constructor itself, and it's an effect that will have to return an implementation of that service.
Right. That makes sense.
Now, but instead of just returning that implementation, you return an effect that returns that implementation.
Yep.
Why? Well, you can do all sorts of effectful things in here, but you can yield other services like this config service that it created as well.
This makes 100% sense.
Created the config tag. And then it has a layer, which is it's using layer succeed because this doesn't need to do anything effectful and it doesn't have any other dependencies.
Right.
So this will just give you, this has a success type essentially that just config.
Yep.
Whereas, because I wish that had types here, greeting live.
So this makes sense.
Has a success type of greeting, but it'll have a third parameter just like Zio has a third parameter of config. Because this implementation. The mythical third parameter.
Yeah.
This one would depend on config, and it infers that based on the fact that you tried to get one in its constructor here.
Yeah.
So if you were defining a user repository service,
right,
you might have a test implementation that just returned succeed, or did an effectful thing and had some map that it pretended that it inserted things into an in-memory map,
right,
and it had no other dependencies. And you'd have a live user repository service that would yield your database service, your Drizzle service, your Prisma, whatever, and maybe analytics, and do all sorts of stuff with all those.
I usually drizzle a little
notice how
Prisma into my effect as well. That makes sense.
oh
Yeah.
my god.
Mm-hmm.
And notice how the interface itself will never have these third parameters there. That's
Yeah.
kind of an anti-pattern. You never want to expose these dependencies in these interfaces. That's generally always going to be built by these layers, which is like these composable Lego pieces
Yeah.
that you use to construct your application in a type safe way.
Mm-hmm.
So this is how you define your services. Like if I want to make a new service,
Yep.
There's actually a way that kind of does all this in once, but whatever. I'll define a tag
Yep.
within the interface. So
Yep.
instead of just defining an interface, I define the interface like this, put it in a tag, whatever, some boilerplate.
Yep.
And then I'll make the live implementation.
Yep.
And I can reach out into other tags. If I can even you can kind of code in this type-driven way where I can start by implementing my user repository live. I didn't even implement the database yet or these other services. I can just quickly generate a tag for them without an implementation, yield that tag, and then write my entire implementation of this live service, which depends on some interfaces that I haven't implemented yet. Later on, I can implement those layers. And then at the top of your program, you can pick, you can provide your app layer. And because greeting depends on config, you have to provide config to greeting live. We could have had a different implementation of greeting live that didn't have any dependencies, and we could have provided that directly. And this is where, what's so nice about this is your program becomes almost pseudocode. Like an abstract syntax tree. It's at the abstraction, it's at the high level of abstraction of your domain. You're yielding the services you care about, calling them, and implementing them at this high level. And then later on, you get to pick the semantics by swapping in different interfaces. Which
and I don't have to pass them around as explicit parameters everywhere. And when I want to say, oh, this thing now depends on that thing, it's just going to automatically happen throughout the thing because I just...
Yes. And because these layer constructors are effects, they can do anything effects can do. So one problem with that example you were giving before about that sort of that top level global reference is, well, what if you need to spin up some external connection to initiate a service? Or what if some some dependency of your user repository needs, first you need to establish your database connection to yield something to something else. It's not just a matter of, you can't always just have these sort of global consts. You might have to have some complicated initialization code that ends up getting, if you've ever done that. I've seen these main files in Scala that have been 5,000 lines long. And they're so hairy and crazy. And
10,000 lines of once cell in Rust. And I have to, they can't even share it anyways.
And the worst part about that is that this becomes the locus of churn. Just a spinning, what is it, Scylla or Charybdis? I don't know. It's a crazy giant whirlpool of death. And because every time anyone, if you have 27 developers on a code base, you're a really successful company of 27 engineers, and you're all editing your file.
Whole Scala ecosystem working at your company.
Exactly. Every Scala developer is working at one company, which is almost true. You're Sirius FM. And you have 80 Scala engineers. You're going to have one giant main file. I mean, maybe you're going to, hopefully, ideally, if you pay them a lot of money, they'll break it out into subfiles. But it's still going to be a lot of work to manage that initialization. What ends up happening a lot of the times, it's one big spaghetti file. And the reason why is because if you have some, let's say you have your greet service, and you don't have layers, I guess, but you have your greet class, and you want to add another dependency to that. Well, now not only do you don't just update the class definition, you also have to go back to that main file and make sure you thread it through that crazy sequence of events. And if it needed to effectfully or sort of asynchronously construct that dependency, you need to put it in the right place and thread through. So that main file becomes very churny. Generally, you would co-locate and define your sort of service definitions in one file, and you can co-locate their implementations. And the top of your application really just becomes this building via providing layers to each other. In this nice way. And there's even an LSP plugin that kind of automatically orders them for you that was just released too. So it's it's not quite a macro, but it'll build it for you. And there's a mermaid chart visualization. Really, I should have put some more work into the layer part of this program. Maybe we can come back another day and give a better pitch for the layers. I think this is mostly in our
this makes sense.
I think you're getting it, but
yeah. Oh, this is good.
Yeah, so that's the crown jewel of Effect is layers, and it's definitely the most complicated, which is why I kind of avoided it. But it's the most complicated. It has the highest learning curve, but also I think the highest reward. And I think I mostly covered everything that I have. That was really fun.
Nice. We just got sent a new link here from Mr. Mike himself.
Effect team.
Yeah.
They're all the 27 effect engineers are typing up, trying to save this.
That's funny.
Sinking ship.
Okay, so let me just read this through and let me make sure I understand. Class database extends effect service database. So this is similar to the idea of what you were just saying, where we can just write this inside of. Oh, this is a little different.
This is the nicer way.
Okay.
This is the nicer way of sort of defining, instead of having, so when I showed the code, there was the tag, which defined like the interface and the key, and then I had to separately define a layer.
Yeah.
This effect.service construction combines both the sort of the default live layer implementation with the tag construction. So
I
this
love
is kind of like,
this totally makes sense to me. This is very cool. Yeah.
You can still construct other layers in the same way. User repo will act as the tag, and the implementation, the interface is inferred by the types of the object that you return. So it's going to give you a service that has get user and get I can't
Is there a way I can see? Nice. There we go. I was saying somewhere in here, I know it has to show database. Right, so we
and you can even hover on effect again. That's a good that's a good idea. So the type of effect is it's going to the layer you're going to get back is going to need a database, and this is basically going to be the interface when you yield a whatever the service is, a user repository. It's going to you're going to have get user and get user, so you can yield this, get back that interface, and then you get a layer for free that you can provide. That's this. Now, there's even another argument you could pass to this called dependencies, and you can sort of
I tried to do BIM mode on here. Sorry,
you booped.
I don't know. Can I write it like this?
That won't. That unfortunately, you can use. You could do effect.fail instead of yielding.
Okay. Yield.
Wrap that in effect.field. Effect.fail.
And then do I just go new error like this?
It doesn't even have to be an error. It could be a string. It could be anything. But that'll work. Yeah. Look at the type now.
Do I not put semicolons here? Is that illegal? Sorry. I don't know. I don't
think it matters. I think it's just recompiling. I'm not sure.
Here, I'll move.
It seems to be sad.
My mouse. I don't know if I wrote that right. We'll copy this one too, and we'll put this in here. I saw a short TJ driving a Lamborghini. That's true. I do have a short of me driving a Lamborghini.
You keep them around.
Well, here I'll. You'll like this. Can you hear my audio? You can't hear it. Let me just go to my channel here. No, not this one. How do I go? View my channel. Here we go. Shorts. This is a classic.
Right here. I can turn up the volume on
car. What do you do for work?
Open source contributor. Neovan, by the way. Classic. Do you daily that thing? I did drive it for one day when we rented it. And then I've never driven it again since then. Guys, the open source bucks are really flowing. Okay, wait. So let me read through this one here. User repo expends user repo here. I did a drive it for one day. Yeah. Dependencies database.default.
Oh, they changed it?
No, he just sent me a new one. He sent me a new one to read. I was trying to read what this one does instead. So I don't know what this thing does. Dependencies read only.
Yeah, so we did just do an office hours yesterday where we kind of break this down in detail. That'll be on the Effect YouTube channel in the next couple days. Effect office hours number 5.
Nice.
All about this kind of structure. We spent an hour on going into the details, but to explain what this does is, so yes, this does a few things simultaneously.
Yeah.
One, you get this tag that you can then yield later on. Like database, if we create the database there, we yield it in the effect for user repo.
Yeah.
And that adds it to a dependency. Now, and then you return the interface, which acts as sort of the default implementation. Cool. Now, if we were to use user repo in our app, usually it would, if we didn't just add that dependencies array, it would know that we needed to still provide a database because we yield one. So we would have had to do that sort of layer.provide thing and provide database.default.
Yep.
But because you specify that dependencies array in this effect service, now the user repo.default layer that you get for free will have no dependencies because it'll automatically use this one. It'll delete them from the service. It's very fancy, but yeah, I think it does use. It does deserve a more lengthy. It's going to be a little difficult, but yeah. Notice how no dependencies, and if you comment out the dependencies line on line 12, it will.
I keep trying to type Vim shortcuts, which is very funny.
Yeah, come on, Maxwell, add Vim, add LSP support.
Very cool.
So yeah.
Yeah. No, that
So
makes sense.
which is a nice thing to have, because in most applications you don't need to do that. And if you depended on multiple things, it would only remove what you defined in that dependencies array. So it would sort of just like everything else, just trim off, slice off the errors that you handle, just slice off the dependencies. There you go. And it can even have the same interface because it's a class. So you just yield me inside of user repo. Wow.
So if I go here,
that's perfect. That's fine. That's fine.
Right.
So that has no dependencies, and it has one method called kit. So now yield kit inside of this.
Right.
And now that you've done this, effect will have, of course.
I don't know.
Well, actually, that's weird. I don't know why that's not loading. But
there you go. It
just depends on database and kit.
Yep.
But now hover on the user repo.default.
Right. So then this one. Oh, if
now it has both dependencies.
Right. To do this now, it'll just say kit. Yeah.
Now just kit.
Yep.
And if you want to, you can provide kit.default, and that'll be erased too. So really now at the top of your application, this is the kind of the beauty of it. This is how you would write everything. Like this has the highest learning curve, obviously, because this doesn't have a direct analogy to async await, whatever. But if you go all in on this, you have the problem with structuring your application is essentially solved. You do everything like this, and it's this beautiful, like co-located method that's super flexible, and you can swap in test layers in your tests. And in production, you basically just provide your app layer. And if you use those default dependencies, you don't really even have to do anything else. It's really fun.
This makes sense. Fun. I mean, in my head, this is just, it is. So in OCaml, the thing that this is kind of like module functors, where a module can take arguments, right? So it's and then you would just pass another module. You can switch out which modules you want, right? It's quite a bit more explicit, so it's annoying if you wanted to add this one did take users and now it takes users and database or something like this, right?
Sure.
But I'm just parameterizing my program. I get not hard coding things. That's what we're doing, just at one layer higher. This is what it feels like to me with services. That makes sense. Yeah.
Okay, cool. I'm glad that tracks. I'm sure some people in the chat might be confused still. There's other resources, and this is something that we definitely want to for the next version. Because there's the two ways of doing things. There's the tag, and then there's this. This is kind of the recommended way, but it came later. They figured it out later, so it's not. Yeah, we're gonna have more best practices documentation.
Right.
Me
yell at the LLM. Never do it the old way, stupid LLM. Do it the good new way.
I'm gonna have a chat with Claude after this.
Yeah, exactly. We'll let him know. No, that makes sense.
Cool. I mean, and then in terms of what else there is to Effect, I mean, this is, as I mentioned, kind of the crown jewel. It's the most complicated bit. That's really nice for big applications. You don't need to learn it right away. And then the rest is just the ecosystem of a bunch of libraries that are built with all of these invariants baked in of the error handling, and they all kind of compose and work nicely together. And it's a joy to use. And then you get all the cool TypeScript tooling. I like it more than Zio. Scala is definitely a language that is less verbose. It has macros. Everything can be a little more concise. But it's actually and I used it for years, and it was the inspiration for Effect. But Effect is honestly nicer to use these days because it just has so much more people maintaining it, so many more people maintaining it. Everything is just better built. They've developed these new patterns that work nicely. It just feels like a very alive and very, I know, I'm very excited about it. If that's not coming across by my slobbering.
When you're writing Effect, for me, this makes sense how I would use this. I'm writing a full stack thing. I want to put stuff on. I want to write a new backend thing. I use Effect. Are people using Effect on the front end? How do they use it on the front end? What I don't understand.
Go to atom.kitlangton.com. So I made another little visualization.
and then kitlangton.
.kitlangton.com. Yes.
Okay.
So these are some visualizers of Effect Atom, which is basically based on Jotai.
Okay.
Inspired by a bit. It's Tim Smart made it, who's a very smart person.
Yep.
It's definitely an example of nominative determinism, and it's basically a combination of Jotai and Effect and React Query or something. So this one's very basic. It's just showing some state,
Right.
and so you have an Atom alternative to use state. So go to the next example. You
That
can
one makes
hit
sense.
left on your keyboard, I think. I think left on the keyboard switches you to the next one.
Ooh, nice. Yeah.
Oh, that's the derived one. Okay, so you could derive an atom by calling this get, and it sort of gets the value of the other atom. So yeah, try increasing this one.
Ah,
and
okay,
you'll see
nice.
that the
Yep. Right.
double count atom will work.
Right. This,
Pretty.
yeah, that one depends on this one. That makes sense. Yep.
And so yeah, go to the next one. Obviously, none of these use effect yet. This one just is even.
I mean, that's
version
effect right here, but
well, that's a very good point. See, this just does some fancy stuff like repeating it. It's another variant of the previous derivation business.
Yeah, that makes sense. Cool.
Okay, next one is okay. This is doing something a little more complicated. Here, let's go to. Is this one using effect?
Oh,
yes.
Here we go.
Okay,
right here. Nice.
So atoms can wrap effects, like they're built into using effects, and it's a little complicated if you're not used to Jotai or what have you. But hit increase right here.
Yep. Oh, hit increase. Okay.
So yes. So what just happened? Well, we have a count atom, which is the same one as before, which stored the count state.
Yep.
And so inside of this dice atom.
Yep.
Inside of the dice atom, we get the count atom, and that creates this dependency in the other atom's value. So whenever that other count atom changes, it's going to invalidate and rerun this dice atom. So count atom couldn't be simpler.
Yep.
That just goes up and down. But the dice atom is where we now wrap an effect. So it's the same effect.gen. We're getting the count. And then we're sleeping. We can sleep in here. And then we are basically rolling that count number of dice and revealing them after a certain order of times.
I love seeing some result.match. That makes me happy. Yep.
Yes. So we have an initial roll. We have a success, and it could fail too, which we might have to handle. Now, when it's invalidated, you'll see that the dice kind of fade out. It's because we're sleeping. So there's that waiting variable. So we know when an effect is in flight.
Yep.
And obviously, in this case, it's sort of simulated, but that would probably be a call to some backend or some other internal system.
Yep, that makes sense.
That you're getting the values from. So yeah, let's go to the next page. It gets cooler. I don't know if I have an example for the really cool one. I might need to send you to the docs.
Waiting. Oh, cool. Okay, I got it. So this success has a thing here that's telling us whether we're currently waiting or not.
Yes, and that gets set to true whenever basically that atom is in flight. You can ignore it and just show the new value when it comes in. But if you want to sort of show that it's loading some new value, you can use that as I'm doing here.
Yes, and it has a value all the time on it. So like it's still, I can always write whatever I need to do in, I'm going to write my things to make stuff, blah, blah, blah. It still always has success.value, even though and then it will, when we actually have done the thing, we're going to get a new value and then we can map them. Okay, that's cool. Yeah.
Exactly. Yep. So go to the next slide here. There's a couple more. So this is the same thing, except now we are theoretically hitting an atom. So we have a city atom. It's type safe once again.
Make city.
And so you can click on another New York or something, and we'll see that it's going to set the city, which is going to kick off the weather atom, which is below.
Yep.
And when we're using the schema stuff, so we get all the type safe and we can parse it from the result. I think this is actually hitting the weather right now.
Yep.
And yeah, so we're effect promise, we're yielding the JSON, we're decoding. And so it's kicked off whenever the city atom changes by calling that get thing on the other atom. It gets its value and links the dependencies in this sort of atom runtime thing. Yeah. Just like it's like Jotai in that regard. So it's like Jotai plus all of effect plus React Query plus some other stuff.
No, this is cool. Yeah.
And the really cool thing is, well, here, there's a couple more, I guess, that are maybe cool. I forget. But I don't think I have an example for the coolest feature, unfortunately. Yeah, skip this one. This one's weird.
We did that
ignore this one. Okay. There is one for liking that shows, this one's hilarious.
Well, that's cool.
So yeah. You can see how many books per year you get. It looks pretty. It's basically the same idea, except this one now has multiple effectful atoms.
Yep.
And so you go to the next one because it also has support for optimistic updates.
Ooh,
so
nice.
If you click on the like button, you'll see that there's the server likes and there's the actual like that you see. So the like that you see updates right away.
Mm-hmm.
And then if you simulate network failures, it's going to roll back.
Yep.
Otherwise, it takes a moment to work.
Yep.
This is based on something that Ethan Nizer did. Shout out to Ethan, has great videos. Anyway, so it has all the support for stuff, but the really cool thing is if you can go to, I posted in the chat, Tim Adams' repo, because I don't have an example for this. He does on here.
Here we go.
And this is like, yes, the promise of full stack effect, I think, is really big, and it's still one of the newer areas of the ecosystem. Obviously, Effect Atom isn't part of Effect yet. It's going to be in V4. So scroll all the way down to RPC integration, because there's this whole, like, I didn't get into it at all, but there's, with schema, you can also derive HTTP and RPC clients from them.
That makes sense.
So if you scroll down a little bit, I think my face is covering the bottom quadrant of the code. So you make these RPC groups. So what is an RPC group? Well, you're basically defining these functions and their return types. So increment is just, it doesn't take any values, doesn't return anything. Count accepts, returns rather a number, it doesn't take any arguments. So you define the interface.
And can't fail.
And it cannot fail. I mean, it can fail with like transport errors and things.
Okay.
No, there's no like first type. You can add an error type, and it would serialize and transmit that as well. So what's interesting is, so then you can use on the front end. Atom RPC. It's a little verbose here, but you'll see basically all it's doing is it's creating this client that uses that RPC group. And what you get from it is online down there where you say use Atom value, count client.query. You give it the name of the function, which is type safe. You have to give it an argument, I guess. And then you can set some reactivity keys. This is like standard React query stuff. So when this is called, this Atom will update whenever that reactivity key is invalidated, which will be by the mutation increment that you call. You define the RPC and whatever, but if you scroll down, I think there's a server implementation. I could be crazy. So here,
count client mutation increment. Okay, cool.
So at the very bottom, on your server, you would basically have the implementation of this. They could share the RPC code. They can share the types, and you would generate an implementation. So this is creating a layer for you. So it's using that layer machinery. My service is an implementation of the count client or something. Or maybe it's not showing me the server. Anyway, I need to come up with better examples. But so you can use it on the front end. You can use it in this type safe full stack way. And it integrates with all the other features. But everyone's going to have to kind of just believe me on this because I didn't make pretty slides that really compress the ideas.
Cool. Yeah, I mean, I was just wondering, like, a lot of the things make sense for how I would want to use them, like, on the back end. But I like trying to figure out how I would also use them, like, on the front end was just more of like a mystery. So it's like, are people using Effect? Like, okay, so I have an Effect backend. Am I just writing, like, are most people right now just doing like React over to here? Like what is the thing that people are doing on the front end to interface with their Effect stuff? If that makes sense.
Yes. So I think a very common pattern. So this Effect Atom stuff is definitely newer. I know Vercel is using it in their new domains thing of Dylan Morroy fame.
I know that.
And Ethan Nizer fame. So they're
Yep.
using the Effect Atom, and it's all full stack stuff.
Oh, okay, nice. I didn't realize they were using Atom though. Okay, got it. Yes.
All right. Yeah. I think he's definitely one of the cutting edge users there. I'm pretty sure, 99% sure. And so they have some full stack. I don't know if it's RPC or HTTP or whatever. But if you don't use that, that's okay. You can still use React Query, and the HTTP server generators that are all type safe and derived from schemas and whatnot. Have OpenAI generation capability built in. So OpenAI.
Yeah, I knew which one you meant, and I was cracking up.
OpenAPI, I do that all the time. They have OpenAPI Swagger. They got some Swagger doc generation, so you can derive from that as well. Or you can, I think you can even just derive a client and not use Atom as well. So you could just use an RPC client in a naked way. So there are many different options. I think one thing, hey, if you'll have me back sometime, I'll prepare I can prepare like a full stack app example. I think that's where, like, now we've gone over I started from the basics,
build one sometime. You don't have to come with one prepared. We'll just go code for 3 hours.
All right, that sounds fun too. Can we bring Dylan on too?
Yeah, but then I'm gonna
I might
mute
need some
him, and
support.
we'll just we'll let him be here screaming on the other end of the
Yeah, we'll keep
camera.
him in a little cage, a little God
No,
box,
I
a
like
little
imagining him
yeah.
being so close to being able to tell me what I'm doing wrong, but then unable to communicate to me. That's some kind of new sort of rage bait torture that we can bring to Twitch. I think is really good. Yes.
I think it's good. Yeah, let's combine the educational
No, we're
material
not
with
gonna
some kind of new
insult
age
Dylan. I'm gonna
sadism.
use effect wrong, and then he'll be mad. I'll just keep on doing. I'll import use effect from React over and over and over, and have him like be really in agony.
Yeah, you should turn off your TypeScript compiler, and only
Oh,
he
there we
can see
go.
the TypeScript output, and then
Yes.
just you could just look at his face and then
Yes.
his gestures. This will be good.
Yes, we'll do it no LSP. Dylan has to tell us what the LSP would be saying. That seems like good. Yeah, Pictionary compiler.
LSP. Let's do it.
No, that sounds fun. Yeah, we should try it again. I'll do a little bit of playing probably. I'm sorry, chat, maybe offline. But I'll probably play a little bit with some of this too, because I've been interested. But this all makes, I mean, for me, this makes a bunch of sense. I'm following with a bunch of the stuff you guys are saying here, and even
Could we get a
yeah,
could
go
we
ahead.
get a decisive gesticulation? Could we get the sort of the gladiatorial finale? Ah!
Ah!
Ah,
Yeah,
yes.
yeah.
All right.
No, it's good. I pronounce effect not deleted. That's my. We don't have to delete the repo after this. Although there is a little part of me that it's like less people are gonna write OCaml because effect exists. You know, it's like less people are gonna write Scala. We're about to kill all the functional languages.
It is a shame. I mean, it is a shame. There are lots of other beautiful languages out there, but I
Yeah,
think there's
yeah,
many
yeah,
other ways to be motivated. Like I think for a long time I was motivated by just beauty, syntactic beauty,
yeah.
language level beauty. But I
Mm-hmm.
think as I've done it for longer, because
Yeah.
I had to work on shitty CRUD apps, so it's like I'm bored of this app. How do I make it interesting for myself? Let's just make this CRUD app as functional as possible.
There we
Like let's
go.
get weird with
Yeah,
Haskell to do this like
yeah.
e-commerce app
Mm-hmm.
with endo functors.
Yeah,
But nowadays, maybe as I've matured or gotten boring or something, it's like what's more exciting is like working on fun projects with interesting people.
yeah.
I mean, and
Mm-hmm.
just the response when I saw Effect getting popular and Pocock posting about it, and then I made this like effect. Could you go to effect.kitlangton.com just to
Yeah,
plug my last visual? Like, if people want to play with what we were sort of doing in the slides, a lot of these examples are here,
yeah.
and you can just I got to get rid of that ugly scroll bar, but it's the same thing with sound effects, and you can play with them, and
Nice.
it all works.
Very cool.
But when I
Mm-hmm.
posted this, I got like it blew any response to anything I'd ever done in Scala out of the water, which
Yeah,
kind of made me like realize, maybe by the course of vanity,
yeah,
unfortunately, by proxy by vanity, like,
yeah,
oh, if I care about effect systems, there's actually
yeah.
hope here because there are people here, and where there are people, there are cool people and they're excited people, and yeah, it's just fun. I would have never been invited onto your stream or get to meet you and have this fun time in Scala. Like, there's benefits of going to where the people are, like going
Yeah.
to the party, and
Yes.
as a program, I tend to avoid parties, but I'm starting to,
Also, I think people are
dip
not
in.
thinking people are going to be writing TypeScript either way. What if we could make writing TypeScript better and applications better that were written in TypeScript? Is you guys there's a complicated world out there with a lot of different trade-offs and a lot of different things going on. We don't have to just say we're going to go over here making incremental progress on stuff. It's allowed. We live in a society bros in shambles. Yeah, no, I mean, it
I'm
seems
over
cool.
you now. This is fun.
Yeah, I know, I was gonna put you back actually. There
Oh,
we go.
damn.
I know, sorry I felt like I wasn't looking at
But
you
chat,
anymore.
what do you think, chat?
Yeah,
What
there
do
you
you
go,
think?
chat. Any last
Comment
thoughts or
below.
questions? I gotta go in like 15 minutes or so. Thanks, Kit, by the way, for spending your whole morning over here with us, or afternoon. I guess I don't remember where you're based.
I'm in the East Coast. I'm
Okay,
in
nice.
New York. Yeah,
Nice, very cool. Yes. Amazing, love it.
that was super fun. Super fun.
Yeah. No, this was
Where
this was cool. Yeah.
where are you?
I live in
located?
Michigan, so
It's probably
we're
not-
in the same time zone.
Okay, all right.
Yeah, contrary to popular opinion, Michigan is still in East Coast time. So a lot of people don't believe me when I say that. My friend, BeaconBot, doesn't believe that time zones exist in the US. He thought I was 1 hour off from him, and he's in California. I'm like, bro, we're far apart from each other, Began. Have you ever looked at a map? Come to Effect meetup in New York, November 19th. I'm going to be on a boat in the middle of the Caribbean, so no. But that would be cool otherwise. Are you going to do right effect
Oh,
on stream? Maybe, yeah. DJ
I
lives
got
in
a
China.
question
He's
about my
lying.
shirt.
What?
I got a question about my shirt, which
Oh,
is it
yes.
a Versace shirt? No, it's not. I don't know what it is, but it's not Versace, that's for sure.
That's funny. I don't know what it is, but it is not Versace. I'm not
Yes, I
abandoning
think it would have shown up in my
OCaml.
bank account as
Yeah.
sorry?
Yes. No. Someone asked, "Am I abandoning OCaml in favor of tech effect?" Yes. I'm still not abandoning OCaml. I'm hoping. I'm waiting for some other things to happen in the ecosystem, maybe, and then we'll go for a run to make a SaaS on it later again. Maybe sometime would be fun. I will post this video on YouTube. Yes.
Cool.
Yep.
Yeah, that was super fun. Thank you all of your millions of viewers.
Millions. This is going to be 1 billion views for effect.ts.
Do you know any other company? I will address this one. Do you know any companies that have adopted Effect other than Vercel? Yeah, a lot of them have. And actually, sort of like if you happen to work for a company, one thing that's really cool about sort of the open source Effect stuff is if you are a company using Effect, they sort of just invite you to their Discord and Slack and give you a private channel, and we'll support you and help you because it's like a selfish. Just as teaching someone is kind of a selfish thing to do because you learn it better yourself. Like it's kind of the whole idea is that if we solve your problems and we see what struggles you're experiencing, we can make the library better. And so it's sort of like free support basically. And it's used by a lot of Y Combinator companies. I don't know why. I think a couple of companies like Mark Prompt started using it. I don't know how many people I could say are using it, but if you look on the internet, a bunch of companies are starting to use it or have been using.
That's one thing I wish more. This like in OCaml, there's just like a lot of people. I feel like just from the outside looking in, this isn't to throw shade at anybody in there, but it's like, why do we care what companies would need to do? And you're like, bro, come on! This is why people build software. Is to solve business problems to make money. Like, I mean, we can keep having to be a toy language and make fun toy things in it, but like, yeah, that part makes me sad. So it's that's fun to hear. That's like, yeah, we're trying to make it so that people can ship real things and do real stuff with it. I like that a lot.
Yeah, we want, I mean, my aspirations, I think effect systems are like what structured programming was in like the 70s to just assembly code. Like, I think it's the next clear, obvious evolution to writing programs. It solves so many problems. And, you know, when structured programming first came out, people were like, whatever, that's too much overhead.
Yeah.
You just got to write the assembly. What is all this indirection? And this is too much syntax. Like, what? That's gross.
Well, they were probably right at the time. Like, we really couldn't afford to do it. Like, why are C functions such short names in the standard library? It's because you could not write out the names long. Like, it would make it so you'd run out of memory on your computer, you know, like, oh man.
No, that's a good point. Like sometimes it's not, the world is not ready for things for various reasons. And you need like, resources, computation to catch up. I think like effect systems have been around for a long time now, starting in like Haskell and propagating out to some other functional languages. But and in the languages that they do exist, I like to say, like they have conquered. Like they are a very successful organism in those ecosystems. It's just that they haven't yet been sort of transplanted into a language like TypeScript. Like there hasn't been another mainstream language like Java couldn't support it until now. And now we've released it and it's slowly exponentially growing and we're all doomed in a very positive way. Is my hope. Of course, there will be like the best part about TypeScript that doesn't exist. I don't know how Clojure is. Scala is known for being an incredibly bloody, sanguinary institution and like an island of dying tribes that are all like it's the. If you look up the narcissism of small differences in the dictionary, or rather in an idiom dictionary, you will see the Scala logo because it is just like everyone's a functional programming nerd, and there's two different effect systems. And everyone hates each other. And it's just like, you guys are like almost identical. What are you doing?
Oh, that's really funny. Yeah.
But in TypeScript, like we have abundance, we have riches, we have like, no one's going to care. Like they'll make fun of effect on Twitter, but they're not worried or like violent about it. They're going to post their little like takedown and move on. And that's great. We can all live together in peace.
Yeah. Sweet. Well, I don't know, chat. Anything else? I don't have anything else. Maybe just some claps for Kit for coming on and hanging out for so long with us. It was a fun stream. I'll try and get this posted.
I was saying earlier when you went away that I wanted to give your brain a CAT scan. Like, have you felt your streaming change, sort of your connections? The corpus callosum has widened. Like,
from today, you're saying?
No, no, in general, just over the course,
Oh,
long-term exposure to streaming. Has it like the London cabbies, like the
yeah.
cabbie drivers when they scan their brains, that they have
The
different.
the funniest one is like it doesn't happen when I just do like a 3 hour stream thing, but like when we finished doing the first like tower stream where we were streaming for a week straight, and like rotating people in and everything, and like just literally 24 hours a day for 7 days straight. It was very funny because as we were cleaning up and I was talking to Adam Eunice, who was there with us, and we were both laughing, like we tried to we tried to say, "Hey, chat," but they're not here anymore. Like we're offline, you know. Like like we tried to say, "Hey, chat," and that doesn't work because we're not on stream anymore. So that
You
takes a little.
manifested a mental illness.
Yes,
That's
yeah,
very
yeah. And it
impressive.
just takes like a little, like, I mean, normally not streaming like that. That's for special events to do something goofy and everything like that, and all these good, good things, right? But yeah, it's like that part was very funny of being like, okay, I'm not on stream anymore. We're not like there's nobody here. There's not people on the other side of the cameras. But yeah, it
They
was good.
don't exist.
Yeah.
You go to a bodega and you're just like
Yes.
talking,
Yeah. Yeah.
making asides in
Yeah.
front of the people.
Yeah.
Cool, cool.
Nice.
Yeah, the fact that you said only a 3 hour stream though to me has shown me already that you have a certain amount of
Oh yeah, no, there's a
diligence
lot
and
of practice that
perseverance.
goes in. I mean, like a long stream would be like 8 hours. That would be like we just do the whole day on stream. Although chat's gonna make fun of me because I haven't been streaming very much in the last 6 months. But that's because we're starting a whole company with Prime. Okay, you guys got to cut me a little bit of slack on that. All right. You guys think Prime reads emails? Can chat just acknowledge somebody has to read the emails for a company, and it's not going to be Prime? That's okay. You want to lean into people's strengths, chat. Okay, that's how you have a successful company with your friends, is lean into their strengths. Okay, so there you go. Ask Prime how many emails he's replied to in the last 6 months, and that explains some of my lack of streaming. Okay, that's all right. That's fun. That's fun. Should hire someone. That's me, bro. You want me to lose my job? Yes, 12 people lost the bet of you not having a sex stream. I had 3 streams this week, so take that, chat. Yeah.
I hope I've offered you a sort of unlimited resource for
Yes.
potential stream
No,
topics
I do want to try
over the
and
next month.
do this. Actually, it was funny. I was messaging. So we have our terminal coffee shop thing. Some of it is written in
Mhm.
TypeScript. I may explore trying out Effect, and some of it we'll see. Dax never replied to me about it, so I messaged Dax and I said, "Hey Dax, do you know if Adam, that's Adam Elmore, vegan, Adam.dev, do you know if Adam doesn't like Effect? Because that's enough reason for me to try and put it in our code base." But he never replied to that, so I'll take that as he doesn't like it. So we're gonna. I don't know for sure. I might try it on a few other projects too. I was also interested on some front end side stuff of it. I've been writing a lot of Elixir. I really like Elixir and been having fun with that. But like sometimes we need to do a little bit more JavaScript stuff on the front end. So then
Sure,
I
sure.
was like, okay, maybe we could try some Effect stuff. That was part of the reason I was asking about how are people writing, Effect for the front end, because that's a place where, like, you just got to write TypeScript, or you got to write, some form of JavaScript things. Yeah.
Yeah, terminal.sh is really cool. I honestly didn't even know that was possible to have to
Oh
sh
yeah.
into a TUI
Yeah.
until
Yeah.
that. I mean, obviously that makes sense, but that's so
Yes.
cool.
Yeah.
Yeah, and I've been using OpenTUI with. You can use OpenTUI with Effect Atom and Effect.
Oh, nice. Yeah, you
Possible
should send me
stack.
that because I may seriously do that. You can send me that later because we're gonna rewrite the front end for terminal.shop to use OpenTUI and stuff
Okay,
sometime.
I'll send you a little demo.
Yeah,
I'll
that'd
send
be
you a little
sweet.
demo.
Cool.
Amazing.
Yeah. All right. Well, that's it. I'm gonna send everyone over to Prime because I think he's live right now. Kit, don't leave. We're gonna go offline in a second. Bye, everybody. Thank you. Kit, anything else you want to shout out? I mean, obviously, you guys can go to kitlangton.com. Very cool site. Lots of different things. Are all of the things you built here linked places? Good. There are.
A lot of yeah, I think so. Visual Effect, Effect
Very
Atom, I
good.
think so. There's Baby Me, some other Scala things
Nice.
you
I
can ignore.
love
Some
this.
videos I made on Effect are in the top one. That Thunk one at
Nice.
the bottom is a good starting place. But if you want more entertainment, obviously the one with the Elmo is, I think, done the best. They're all pretty deranged, so I do recommend.
Ooh, nice. I like this. Very cool. Nice.
Cool. But yeah, reach out on Twitter. Follow me on Twitter. It's a link here too. And yeah, let me know if you have any Effect questions. There's an Effect Discord, which is really active, and people are very responsive. Like, it's not. I'm just like the guy who joined recently and has been making a lot of videos and content.
Yeah.
Like I had an awakening that TypeScript is the way.
Nice.
And I just want Effect to succeed, and this feels like an important moment. So
Yeah.
talk to everybody else. They're super nice. I mean, there's a whole team. My brain is blanking. Obviously, Michael Arnaldi, the vampire, and
the vampire,
and Maxwell Brown, and Tim Smart. Anyway.
Mike,
So
I'm expecting a vampire costume for Halloween. Okay, so I don't know what you were planning on going before, but Mike, if you're still listening, I'm expecting to see some vampire pics on Halloween this year. So,
thanks everybody for tolerating.
It's a daily costume. All right, well, I'm gonna send the raid to you guys. Thanks everybody for hanging out. We'll probably be back tomorrow. Bye. Goodbye,
Bye.
Twitch. Goodbye, X.com, the everything application.